They were never meant to last this long. 2 spacecraft, no larger than a small car, launched into the black void with hopes, not promises. In 1977, when Voyager 1 and Voyager 2 departed Earth, no one could predict what they'd find. They carried with them golden records, messages from humanity etched in metal, hoping that one day, someone, or something, out there might listen. But what they uncovered, far beyond the orbits of planets, would go far beyond alien greetings. What they discovered was the very nature of space itself, torn apart, redefined, and utterly shocking. But before we continue, subscribe to the channel and like the video. The edge of the solar system was once imagined as a distant, static boundary, a wall between the known and the unknown. Scientists had models, maps, predictions, and mathematics. But as Voyager approached this cosmic frontier, something extraordinary happened. The models began to fail. The data that returned to Earth did not align with expectations. It was as if space itself were whispering secrets from the edge, truths humanity had never known and perhaps was never meant to find. Voyager didn't just pass through planets. It passed through ideas. It tore through what we thought we knew about magnetic fields, the sun's influence, interstellar winds, cosmic particles, and the protective shield that keeps Earth safe. It revealed violent transitions in space plasma, mysterious fluctuations in magnetic fields, and the haunting silence of interstellar space. The edge was not an edge at all, it was a battlefield, a frontier, a breathing, ever-changing membrane between solar protection and the cold, ancient universe beyond. This script is your portal into that astonishing journey. For the next 3 hours, prepare to drift alongside Voyager through magnetic chaos, particle storms, and eerie emptiness. We will travel from Earth to the heliopause, the true edge of the sun's influence, and beyond. We will explore every major and minor discovery these twin spacecraft revealed. We'll talk about how their instruments defied time, how their findings shocked NASA, and how even now, in the freezing dark, they continue to speak. This is the story of what the Voyagers found, not in space, but between spaces. This is what happened at the true edge of the solar system. When the Voyager missions were first conceived, the goal was simple: take advantage of a rare planetary alignment that happens once every 176 years. It was the perfect chance to slingshot a spacecraft from planet to planet using gravity assists. Voyager 2 was launched first, on August 20, 1977, followed by Voyager 1 on September 5. Voyager 1 would reach Jupiter and Saturn first, and continue on a trajectory that took it faster and farther than any human-made object before. Voyager 2 took a slightly slower path, enabling it to encounter Uranus and Neptune, the only spacecraft ever to do so. And yet, those flybys, as magnificent as they were just the beginning. As the spacecraft journeyed outward, they crossed several invisible boundaries that scientists had theorized but never measured directly. One such boundary was the termination shock, the point where the solar wind slows down abruptly as it begins to collide with the interstellar medium. It was once thought to be a gradual transition. It wasn't. Voyager 1 crossed the termination shock in December 2004 at a distance of about 94 astronomical units, AU, from the Sun. What it found there was turbulence, a chaotic mixture of slow and fast solar wind, a place where particles danced unpredictably, guided by unseen magnetic forces. Voyager 2 would cross the termination shock in 2007 at a different location and a different distance, around $84. This discrepancy stunned scientists. Why would 2 spacecraft, launched at roughly the same time, cross the same boundary at different distances? The answer revealed something deeply unsettling. The heliosphere, the bubble of solar wind that surrounds our system, was not a sphere at all. It was distorted, compressed, shaped by external forces, possibly even by the magnetic field of the Milky Way itself. The edge of the solar system wasn't round. It was lopsided, and perhaps alive. Even more startling were the plasma wave measurements. Voyager's plasma wave subsystem, PWS, a seemingly humble instrument, began detecting bizarre high-pitched tones after crossing the heliosheath, the region beyond the termination shock but before the heliopause. These tones were evidence of interstellar plasma, dense, cool regions of gas not found within the solar wind. They oscillated at unexpected intervals, increasing in frequency as the spacecraft moved further out. In 2012, when Voyager 1 finally crossed the heliopause, the true boundary between solar and interstellar space, it was not a dramatic event. There was no explosion, no wall. But the instruments recorded an undeniable change. The solar wind was gone. The particles around the spacecraft were no longer emitted from the sun Voyager 1 had left home. This was a moment of cosmic history. For the first time, humanity had created an object that passed into interstellar space. And what Voyager found there was silence. The kind of silence that speaks volumes. No more solar wind. No more magnetic alignment with the sun. But something else, a steady hum of plasma waves, indicating a denser environment. Interstellar space, it turned out, was not empty. It was structured. It had temperature. It had pressure. It even had direction. The magnetic fields no longer matched those of the solar system, and that shift, that subtle pivot, was a whisper from the galaxy itself. Voyager 2 would make its own crossing in 2018. Unlike Voyager 1, it still had a working plasma instrument. And it confirmed everything, and then some. It measured a sudden increase in plasma density by a factor of 20. It detected a steep drop in solar wind particles. It found interstellar space to be shockingly active, not dead. Waves of plasma rolled past the spacecraft in rhythmic pulses. The environment was colder but richer in information than anyone imagined. The space beyond the sun was not a void. It was a sea. Yet even more shocking than what Voyager confirmed was what it contradicted. Models of the heliosphere predicted certain magnetic alignments, but the spacecraft found misaligned fields, twisted, unpredictable lines that wove through space like threads in a chaotic tapestry. Some scientists believe these may hint at even larger galactic processes, forces operating at the level of the Milky Way, pulling and shaping our solar bubble in ways we can barely comprehend. And then there were the cosmic rays. As the spacecraft left the sun's protective influence, they began to detect a flood of high-energy particles from distant supernovae. These particles had been partially deflected by the heliosphere but now entered freely. Voyager's data showed that the heliopause acts like a shield, blocking much of this radiation from reaching inner planets like Earth. Without it, life on Earth might not even exist. Voyager helped define the boundary of safety for our world, a boundary made not of rock or matter, but of invisible winds and magnetic deflections. Each instrument on board Voyager played a role in this revelation. The low-energy charged particle instrument, the magnetometer, the cosmic ray subsystem, the plasma wave subsystem. Each one, working far beyond its expected lifespan, sent back pieces of a puzzle that, when assembled, showed a cosmic barrier, not sharp like a wall, but soft like skin, full of pores and pulses and secrets. The spacecraft were not just explorers. They were messengers. And what they sent back changed everything. The signals were faint. It often took over 18 hours for data to return to Earth. But the insights were immense. One of the most eerie findings was the cosmic hum, a low-frequency tone, detected by Voyager 1, that emanated steadily from interstellar space. Unlike the solar wind's fluctuations, this tone was unchanging, like a background song of the galaxy. It was the voice of deep space, never heard before. A sound not caused by stars or planets, but by the ambient plasma itself. And then came the anomalies. Unexpected surges in cosmic ray density. Bizarre particle flows that reversed direction. Magnetic field rotations that defied solar models. Some scientists even speculated about hidden forces, structures in space we cannot yet detect. Were there interstellar clouds? Magnetic highways? Ghost fields? Voyager's data raised questions that have yet to be answered. But perhaps the most profound discovery was not physical, it was philosophical. The Voyager probes reminded humanity of its smallness. These spacecraft, built by human hands, had traveled further than any living creature, through conditions no life could survive, into realms no eye had seen. And still they spoke. Still they transmitted. Against the cold, against the odds, they continued. Voyager continued on, past the reach of any planet, past the gravitational whispers of even the most distant celestial bodies. And as it moved deeper into the uncharted territory of interstellar space, it kept speaking in ones and zeros, fragile signals received by the deep space network, parsed by computers, and interpreted by human minds eager to understand what lay beyond. The next wave of discoveries was not just about what was out there, but what those things meant for everything in here, including the very definition of our solar system. One of the earliest assumptions that Voyager shattered was the idea that the heliopause, the final boundary where the solar wind stops, would be a fixed, permanent line. Voyager's readings suggested otherwise. When Voyager 1 crossed the heliopause in 2012, scientists expected a clear and stable transition. But the data told a different story. The boundary wasn't uniform. Instead, it fluctuated. It pulsed. In fact, the spacecraft seemed to dip in and out of the interstellar medium at times, as if the edge of the solar system were breathing. These fluctuations hinted that the boundary was not a static line but rather a dynamic and living interface, one shaped by both the sun's outflow and the pressures of the galactic medium beyond. What does it mean for a boundary to breathe? Imagine the heliosphere as a kind of balloon, inflated by the solar wind, but also compressed by external forces. As the sun's activity changes over its 11-year cycle, the pressure of this wind increases and decreases. When the solar wind weakens during solar minimum, the interstellar medium pushes inward. When solar activity intensifies, the bubble swells again. Voyager revealed that this interplay was not subtle. It was dramatic. And it occurred on timescales we hadn't accounted for. These movements weren't just theoretical fluctuations. They were real, measurable, and shockingly large. The magnetic field data was equally astounding. Voyager 1's magnetometer showed a sudden and persistent rotation in the direction of magnetic lines once it entered interstellar space. This meant the magnetic field inside the heliosphere, governed by the Sun, was no longer dominant. A new field took its place. But that field was not perfectly aligned. In fact, there was an angle of about 40 degrees between the interstellar magnetic field and the solar magnetic field. This seemingly small discrepancy had enormous implications. It suggested that the Sun's protective bubble did not smoothly merge with the galactic environment, but instead clashed with it, like two waves crashing in opposite directions. This finding led scientists to reevaluate the heliosphere's very shape. Early models had envisioned it as a sphere or teardrop, shaped like a comet's tail, with the Sun at the center and a long trail behind it due to the movement of the solar system through the galaxy. But Voyager's data questioned this. Some now suggest that the heliosphere may resemble a croissant, pinched and twisted by external magnetic forces, its shape sculpted not only by the Sun but by the very galaxy itself. Others have posited it as more of a bubble with rippling edges, like a jellyfish caught in a galactic current. Whatever its form, Voyager proved that the boundary wasn't smooth, and it wasn't still. Then came the measurements of galactic cosmic rays. These high-energy particles originate from outside the solar system, from events as cataclysmic as supernovae and as distant as galactic centers. Inside the heliosphere, the density of these rays is significantly lower because the solar magnetic field deflects many of them. But Voyager found that just beyond the heliopause, the intensity of cosmic rays surged. This surge wasn't gradual. It was immediate. And it revealed something critical. The heliosphere is our radiation shield. Without it, Earth would be bombarded by lethal energy from the stars. The implications for planetary habitability were profound. Any planet without a magnetic field or a protective heliosphere, or equivalent, would be constantly bathed in these high-energy particles. Life as we know it could scarcely survive such conditions. Voyager had not just mapped the outer limits of our solar system. It had shown where the walls of our cosmic shelter truly stood. But perhaps even more fascinating were the low-energy particles. Voyager's instruments began detecting a population of particles moving in unexpected directions, often perpendicular to what models had predicted. Some came from the Sun. Others did not. This led to a flurry of hypotheses. Were these particles being accelerated by magnetic reconnection events? Were they remnants of ancient solar storms that had diffused over time? Or were they evidence of interactions we didn't yet understand, perhaps even involving structures in the interstellar medium? To further complicate matters, Voyager also recorded waves. Not just plasma waves but magnetic and density waves in the interstellar medium itself. These waves would pass through the spacecraft, altering particle densities and magnetic fields temporarily before returning to a steady state. It was as if the spacecraft had entered a sea, not calm, but filled with tides, undercurrents, and hidden storms. And then there were the islands of pressure, dense regions where interstellar plasma clumped together in unanticipated ways. Voyager 2's more advanced plasma instrument detected these pressure pockets, and found that they corresponded to sudden spikes in magnetic field strength. These were not random. They seemed to form patterns, almost as if something were guiding them. Perhaps interactions between the interstellar medium and remnants of past solar activity? Perhaps ancient shockwaves? The questions grew deeper, and Voyager, still alive, still listening, continued to transmit data at the speed of patience. Now consider the temperatures Voyager was measuring. Beyond the heliopause, scientists had expected space to be colder, and it was. But not uniformly. Some pockets of space were colder than others, and some were unexpectedly warm. The density of plasma increased, and with it, temperature variations became more complex. This raised the tantalizing possibility that interstellar space was not homogeneous. It had weather. It had climate. It had fluctuations that Voyager could detect but not explain. The spacecraft also recorded abrupt magnetic field reversals, events where the magnetic field suddenly flipped direction for a period of time before returning to its previous orientation. These reversals, some lasting days, some weeks, suggested that interstellar space might have its own magnetic turbulence, not driven by our Sun, but by galactic forces at large. Were these signs of hidden galactic structures? Could they point to the direction of ancient stellar winds? Voyager was gathering clues to mysteries no one had even thought to ask. And still, the twin explorers endured. Their instruments, operating decades beyond their expected lifespan, kept functioning with ghostly precision. Every day, they grew more distant, Voyager 1 hurtling toward the constellation Ophiuchus, Voyager 2 in the opposite direction toward Sagittarius. But their voices, faint though they were, continued to be heard. Each byte of data they transmitted was a whisper from the edge, a cosmic telegram delivered across the ocean of stars. The golden records they carried, copper phonograph records containing sounds, images, and music from Earth, were designed not for humans but for the unknown. Messages in 55 languages. Songs by Bach and Chuck Berry. Greetings from children. The crackling sound of a kiss. These records ride aboard the spacecraft like time capsules, bearing the essence of humanity into the eternal dark. But as poetic as those records are, they pale in comparison to the scientific legacy the Voyagers built. These spacecraft weren't just emissaries. They were witnesses. They saw the sun's reach end. They saw the galaxy begin. As Voyager continues its journey, it will pass through several more invisible layers of space, including the so-called bow shock region, where the interstellar medium is deflected around the heliosphere like water around a boat. If this region exists. Because Voyager's data also challenges the existence of the bow shock. Early models suggested that as the solar system plows through the galaxy, a shockwave should form in front of it. But Voyager has yet to detect one definitively. Some now believe the shock may be more of a gentle wave, or might not exist at all. This single mystery, bow shock or no bow shock, may rewrite entire models of how our solar system interacts with the galaxy. It could alter how we think about star systems moving through space. And it's just one of dozens of enigmas Voyager continues to expose. Voyager's discoveries did more than redraw the map of the solar system. They reframed how we think about the universe itself. The region beyond the heliopause, once considered an empty void, is now seen as a dynamic and richly structured expanse filled with magnetic fields, particle storms, and subtle flows of cosmic matter. Voyager made the invisible, visible. It transformed a hypothetical boundary into a living frontier. One of the most haunting revelations involved the longevity of solar influence. Voyager found that even tens of billions of kilometers from the Sun, remnants of solar activity still echo through the darkness. Solar eruptions, coronal mass ejections that occurred years before, were still traveling outward, pushing and pulling the interstellar medium as they went. Some of these waves took over a year to reach Voyager, like thunder rolling across a vast and silent plain. When they passed, the spacecraft detected spikes in plasma density and magnetic activity, as if the ghosts of solar storms had come to brush against the edge of the known. Even light itself, once presumed to fade into irrelevance at such distances, took on new meaning. Voyager's instruments revealed the persistent glow of hydrogen atoms, the most abundant element in the universe, flowing into the solar system from the interstellar medium. These atoms were deflected by the heliosphere's invisible walls, but they still managed to seep through. By analyzing this faint hydrogen glow, scientists could map the structure of the heliosphere from the inside out, building a three-dimensional picture of its shape, motion, and interaction with galactic forces. And then there were the interstellar particles, grains of dust and matter drifting between stars. Voyager captured and cataloged them, measuring their velocity, direction, and composition. These grains, thought to be evenly distributed, turned out to follow patterns. Some clumped together. Some were larger than expected. Some moved against the flow, hinting at local turbulence in the interstellar medium. Each grain held a secret, a chemical signature of its origin. Some may have been born in supernovae. Others may be older than the Sun. Voyager turned dust into data, and data into history. The spacecraft also gave us unprecedented insights into the transition between solar and galactic space. Before Voyager, scientists assumed that the shift would be abrupt, a sharp line between one domain and the next. But the truth was messier. The transition zone, the so-called heliosheath, turned out to be hundreds of millions of kilometers thick. Within it, Voyager found that particles didn't behave according to the neat models of textbook physics. Instead, they swirled, slowed, and then accelerated again. Some magnetic lines reconnected, while others fractured and reformed. The heliosheath became a laboratory of plasma physics, a place where the rules bent, twisted, and sometimes broke. This region also revealed one of Voyager's most stunning surprises, the presence of anomalous cosmic rays. These were particles that originated not from outside the solar system, but from within, specifically from the interstellar medium that had entered the heliosphere and been reaccelerated near the boundary. These particles were not predicted. They had no clear source. But they suggested that the edge of the solar system was not just a barrier, but a particle factory, a place where magnetic fields, plasma flows, and shock waves interacted in unpredictable ways. Voyager also helped confirm that the Sun's influence isn't simply electromagnetic. It's gravitational, yes, but also particle-based. Even beyond the heliopause, solar particles continue to leak outward. Some travel on ballistic trajectories. Others spiral along magnetic lines. The solar system doesn't end at a wall. It fades, slowly, subtly, like the thinning of atmosphere at the edge of space. Voyager was our first probe to track this thinning in real time, giving us a continuous, detailed account of how our star loses its grip on space. All of this data didn't just revolutionize astrophysics. It reshaped our understanding of habitability and protection. We now know that heliospheres around other stars may offer the same kind of shielding, and that planets within them are safer from galactic radiation. This, in turn, has redefined how we search for life in the universe. Voyager's findings suggest that to find a habitable world, we must also find a protective bubble, a magnetic shield, a guardian star. This has profound implications for exoplanet science, galactic habitability zones, and the search for Earth-like worlds. Voyager's mission also raised deeply philosophical questions. As it ventured farther and farther into the abyss, it reminded us how small and fragile we are. The famous pale blue dot image, taken by Voyager 1 at Carl Sagan's urging, showed Earth as a single pixel, suspended in a sunbeam. That image became a cultural touchstone, a symbol of both humility and hope. But Voyager's continued journey turned that metaphor into motion. It was no longer just a snapshot. It was a voyage. A real-time story of how humanity reached out, touched the stars, and kept going. And go it did. Even as power levels dropped, and instruments began to shut down one by one, Voyager's core systems held firm. Its radioisotope thermoelectric generators, fueled by decaying plutonium-238, continued to provide enough power to transmit data back to Earth. NASA engineers began turning off non-essential systems to conserve energy, choosing which sensors would live and which would sleep. Every watt was precious. Every decision irreversible. It was like running a candle through a hurricane, slowly, delicately, preserving the flame. Meanwhile, the Deep Space Network, a global collection of massive radio antennas, continued to listen. These antennas, some the size of football fields, strained to detect Voyager's signals, which by now were as weak as the light from a distant star. The data rates slowed to mere bits per second. It could take hours to send or receive a single command. Yet the connection held. Across the gulf of 24 billion kilometers, a dialogue persisted, a testament to engineering, patience, and the relentless human drive to know more. Each day that Voyager survives, it pushes the boundaries of knowledge. It travels roughly 1.5 million kilometers farther from Earth every 24 hours, yet it remains tethered to us by a whisper of radio. That whisper has already outlasted Cold Wars and technological revolutions. It has outlived its creators, its designers, and many of the assumptions that once guided it. It has become the longest-running scientific mission in human history. But Voyager's true legacy lies not just in its data, nor even its distance. It lies in its defiance. It was built to last 5 years. It has lasted nearly 50. It was launched to explore planets. It has explored the stars. It began as a probe. It became a pioneer, a pathfinder, a symbol. And still, it flies. As Voyager continues its silent journey into interstellar space, its role shifts from explorer to messenger, a vessel not only of science, but of story. The farther it drifts, the more it embodies humanity's longing to reach beyond its own world, to cross the vast emptiness that once seemed eternal and impassable. Even though its primary instruments are gradually shutting down, and even though its radio signal will someday fade into static, the spacecraft itself will continue on for millions, perhaps billions, of years. A frozen artifact of Earth, tumbling quietly between the stars. Within Voyager's frame lies a message unlike any other sent by our species, the Golden Record. Encased in gold-plated copper and sealed aboard both Voyager 1 and 2, the record is a time capsule, a greeting to any intelligent life that might one day recover the probe. It contains 116 images encoded in analog format, as well as a variety of natural sounds from Earth, from thunder and birdsong to the gentle rustle of wind. There are spoken greetings in 55 languages, and a printed message from then-President Jimmy Carter and UN Secretary-General Kurt Waldheim. There is music, from Bach and Beethoven to Blind Willie Johnson and traditional folk songs from around the world. The record's inclusion was both poetic and practical. It offered no scientific advantage, no direct mission utility. But it was an act of hope, the hope that someone, somewhere, someday might find it and understand. That long after the Earth has changed, long after human memory fades, this tiny voice might still be heard. The Golden Record is not just a communication device. It is a statement that humanity once existed, once dreamed, once reached out. Even the engineering of the record was visionary. Its surface includes diagrams that describe how to play it, using only physics and mathematics as the language. Pulsar maps etched onto the cover show Voyager's point of origin within the Milky Way, allowing a sufficiently advanced civilization to triangulate Earth's location at the time of launch. In a way, it is both an invitation and a breadcrumb trail. It is the closest thing to immortality we have ever made. As Voyager crossed into interstellar space, it also carried with it a piece of our collective psyche, the notion that our desire to explore cannot be extinguished, even by the infinite. Its crossing of the heliopause, a milestone once dismissed as unreachable, proved that borders are illusions. The universe does not end at our doorstep. It simply begins again, in stranger forms. The discoveries Voyager made in the heliosheath and beyond remain subjects of intense study even today. Scientists pore over the fluctuations in plasma density, the shapes of magnetic field lines, the interaction zones where solar wind and interstellar medium collide like ocean currents. Each reading from Voyager's instruments, however delayed or degraded, contains data that can reshape how we model cosmic physics. One of the more mysterious findings in recent years involved the detection of a persistent, low-frequency hum in interstellar space. Voyager 1 first recorded it in 2017, and it continued into the 2020s. Scientists determined that it was not caused by solar activity, but rather the vibrations of plasma in the interstellar medium itself. This hum, a kind of cosmic whisper, had never been directly observed before. It suggested that space between stars is not as silent as we once believed. Instead, it is filled with subtle, constant energy, vibrations that hint at a hidden structure within the void. Another breakthrough came with the realization that the interstellar medium is not uniform. Voyager revealed variations in density, temperature, and composition that suggested nearby events, such as supernovae or interstellar shockwaves, may be shaping the local space environment. This challenged the previous notion that the interstellar medium was like a calm, featureless ocean. Instead, it is more like a weather system, dynamic, reactive, and filled with surprises. Voyager also contributed to our understanding of how cosmic rays behave as they cross boundaries. By tracking their intensity and direction at various distances, Voyager provided data that allowed scientists to fine-tune models of radiation shielding, models that are crucial not just for astronomy, but for the future of human space travel. Any crewed mission to deep space must reckon with cosmic radiation, and Voyager's readings offer a real-world benchmark for what awaits beyond the solar wind's protective curtain. The spacecraft's magnetic field instrument, though relatively simple by today's standards, has delivered stunning insights. As it crossed into interstellar space, Voyager detected a sudden and dramatic shift in the orientation and intensity of magnetic field lines. These lines, which had flowed outward from the Sun in spiral formations, gave way to new patterns, aligned not with the Sun, but with the galaxy itself. The data showed that magnetic fields in interstellar space are more tangled and compressed than previously thought, potentially due to the movement of the solar system through different regions of the galaxy. Such revelations have direct implications for space weather and the long-term habitability of planetary systems. They help researchers predict how solar systems evolve, how stars shape their surroundings, and how planets, including exoplanets, are shielded or exposed over cosmic timescales. Even Voyager's signal degradation has become a data point. As the spacecraft's instruments weaken and its systems age, engineers must decode increasingly faint transmissions. But in doing so, they're developing techniques that can be applied to future interstellar probes, or even to radio astronomy missions that listen for signals from distant civilizations. Voyager's endurance is teaching us not just about space, but about communication at the edge of silence. And silence is near. Within the next few years, both Voyager 1 and 2 will run out of usable power. Already, some scientific instruments have been shut down. Others are operating at minimal capacity. Engineers at NASA have managed to squeeze every last electron out of the spacecraft's power system, even performing creative reconfigurations to bypass glitches and memory faults. But Entropy is relentless. The day will come when no more signals are sent, when no more data arrives. Yet even then, Voyager will continue its journey. It will pass through the Oort cloud in the next few hundred years, a vast sphere of icy bodies that surrounds the solar system. From there, it will drift into true galactic space, orbiting the center of the Milky Way along with the stars. It may pass near other stars in 1,000,000 years, or 1,000,000,000. It may outlast Earth itself, if humanity does not survive. It is a silent witness to all we have ever been. In this way, Voyager becomes something more than a machine. It becomes a monument, not of stone or metal, but of trajectory. A moving sculpture of curiosity and courage. Its path through the stars is a testament to what we value, what we choose to remember, and what we dare to seek. As Carl Sagan once said, "The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space." But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Hope, perhaps, is the most shocking discovery of all. The Voyager mission, even in its twilight years, continues to serve as a scientific crucible, not only expanding our knowledge but challenging deeply held assumptions about space, time, and our place within the cosmic theater. With every bit of data transmitted across billions of kilometers, it reaffirms a simple truth: that exploration, no matter how distant, enriches the present and sets the stage for a more expansive future. In the years since the spacecraft crossed into interstellar space, its discoveries have continued to ripple through the scientific community. One of the profound revelations was the concept of the bow wave, or astrosphere, created by the Sun as it moves through the galaxy. Much like how a boat traveling through water creates a wake, or how a comet forms a tail, the solar system drags along a bubble of charged particles and magnetic fields known as the heliosphere. For decades it was assumed that this heliosphere had a clear, rounded boundary, a sort of bubble-like shield around the solar system. But Voyager's data challenged that. As it approached and crossed the heliopause, scientists began to realize the heliosphere may not be a perfect sphere at all. It may be more like a comet's tail, elongated, asymmetrical, possibly distorted by magnetic pressures from interstellar space. This new model has significant implications. If the heliosphere is not a uniform bubble but instead is compressed in some directions and extended in others, then the protection it provides to the solar system from cosmic radiation is also uneven. Voyager's journey helped reshape the three-dimensional map of our cosmic neighborhood. Furthermore, Voyager revealed that the boundary of the heliopause is not a hard wall, but a complex, transitional region. Instead of being a sudden shift from solar influence to galactic space, the transition is turbulent, layered, and subject to change over time. This revelation has ignited new studies in plasma physics and magnetohydrodynamics, deepening our understanding of how particles and fields interact on vast scales. Perhaps even more fascinating are the subtle anomalies Voyager has detected. One such anomaly involves the orientation of the magnetic field just outside the heliopause. It was expected that the magnetic field direction would change dramatically upon crossing the boundary. After all, this marks the end of the Sun's influence. But Voyager found that the magnetic field orientation remained surprisingly similar before and after the crossing. This led to speculation that the solar magnetic field might somehow be entangled or interacting with the interstellar magnetic field in ways not previously modeled. Some physicists even suggested the possibility of a magnetic connection, or draping effect, wherein the interstellar field lines wrap around the heliosphere, blending at the boundary. Another shock came from the plasma density measurements. After crossing into interstellar space, Voyager 1's plasma wave instrument detected a density of particles that was far higher than expected, about 40 times greater than the density inside the heliosphere. This challenged previous models of the interstellar medium, suggesting that the Sun's neighborhood is denser and more active than theorized. Interestingly, Voyager 2's crossing a few years later recorded different values, indicating that the heliosphere is not only shaped by internal dynamics but by the fluctuating, perhaps stormy environment of interstellar space. Voyager's capacity to observe these phenomena rests on its slow but steady transmission of radio signals. These signals, emitted by a transmitter that's now less powerful than a refrigerator light bulb, take over 22 hours to reach Earth at the speed of light. The Deep Space Network, a global system of massive antennas, listens with the patience of a monk, capturing these faint whispers from the edge of known space. To extract meaning from them requires advanced algorithms, signal boosting, and often a good deal of creative engineering. In fact, the process of extracting useful data from Voyager's weak signals has itself become a field of study, refining methods that could be used to communicate with future missions sent far beyond our solar system. Even Voyager's decay has taught engineers and scientists valuable lessons. The gradual degradation of its power systems, thermal blankets, gyroscopes, and memory storage has prompted extensive research into long-duration spaceflight technologies. These lessons have informed the design of new spacecraft, including missions aimed at Mars, Europa, and even proposed interstellar probes. The spacecraft's resistance to cosmic ray damage, micrometeorite impacts, and extreme cold serves as a case study in long-term durability, a blueprint for endurance in the harshest environments imaginable. Voyager's ongoing relevance is also tied to its human element, the team of engineers and scientists who've supported it for over 4 decades. Many of them have worked on the mission for their entire careers, passing knowledge from one generation to the next like an oral tradition. The culture of problem-solving, of squeezing utility from ancient code and hardware, represents a golden age of space ingenuity. When a software glitch or unexpected power drop threatens Voyager's functionality, these engineers don't have the luxury of modern systems. They must recall, sometimes from old binders or punch card archives, how 1970s technology was designed to behave. In doing so, they preserve a kind of institutional memory that is rare in modern aerospace. One particularly moving episode involved Voyager 1 in 2022. It began transmitting corrupted telemetry data, gibberish, essentially, that could not be interpreted by mission control. Engineers worked for weeks to determine the cause, scouring old documentation and system diagrams. Eventually, they discovered the spacecraft had somehow begun routing data through a defunct onboard computer. By reconfiguring the communication paths remotely, from over 23 billion kilometers away, they were able to restore normal operations. This event underscored the remarkable human element behind the mission, an act of remote surgery on a spacecraft in interstellar space. Yet, as Voyager's systems wind down, and as the instruments are shut off one by one, there remains an unshakable sense of melancholy, not from failure, but from a mission fulfilled. Each remaining instrument is prioritized, every watt of power rationed like breath in a vacuum. Decisions must be made. Should we keep the plasma wave instrument on, or the magnetometer? Should we retain the low-gain antenna or conserve power for cosmic ray sensors? These are choices of scientific philosophy as much as engineering. What questions matter most when facing the end? And then there is the golden record, perhaps the most poetic artifact ever sent into space. Not because it will likely be found, but because it was made. It is humanity distilled, the sound of a baby crying, the crash of surf, the laughter of friends. It holds mathematical patterns and chemical formulas, star maps and anatomical diagrams. It speaks in voices from every continent. It says, "This is who we are. We existed. We cared." Carl Sagan, who chaired the committee that curated the record, wrote, "The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. That hope, encoded in golden grooves, floats now among the stars. As Voyager fades, its data continues to be analyzed, reanalyzed, and debated. Some scientists believe its readings hint at the presence of interstellar clouds, pockets of gas and dust drifting between stars, possibly the remnants of ancient stellar explosions. Others believe Voyager is revealing something deeper, that the boundary of the solar system is not fixed, but dynamic. That it breathes, shifts, and pulses with time, affected by solar cycles, galactic pressures, and unknown forces beyond. In the coming centuries, Voyager will pass within several light-years of other stars. In about 40,000 years, it will come relatively close to the star Gliese 445, in the constellation Camelopardalis. It will not slow down. It will not be captured. But in some distant age, should another civilization cross its path, they may retrieve the golden record. They may decipher our music, our voices, our laughter. They may know we once reached out, not to conquer, but to connect. And so, the most shocking discovery Voyager made at the edge of the solar system may not be about plasma, or magnetic fields, or cosmic rays. It may be the realization that humanity, given the chance, will choose to explore. That our need to know outweighs our fear. That even in the coldest, darkest corners of space, a tiny piece of Earth can still shine. As we continue to analyze the remarkable data transmitted by the Voyager spacecraft, we realize that the true magnitude of its discoveries transcends the physical measurements of plasma, magnetic fields, and cosmic radiation. It reflects our thirst for knowledge and the drive to venture beyond the boundaries of what we understand. The Voyagers have become more than just scientific instruments. They are symbolic messengers of human ambition, an embodiment of our desire to know the unknown, and the legacy of an era where curiosity, creativity, and perseverance conquered the vast, inhospitable reaches of space. The longevity of Voyager's mission is a testament to its engineering. When the spacecraft were launched in 1977, the idea of a probe traveling beyond the reaches of the solar system seemed audacious, almost fantastical. Yet, here we are, more than 4 decades later, with Voyager 1 and 2 still functioning and sending back valuable data from the farthest corners of our solar system. They have continued to outlive expectations, not just in terms of physical survival but also in the scientific revelations they have produced. Each data point they send back is a new puzzle piece in the cosmic picture, revealing more about the true nature of the universe. One of the most astounding aspects of the Voyager mission is the information it has provided about the space environment at the edge of the solar system. Previously, scientists could only hypothesize about the conditions in interstellar space. Now, thanks to Voyager's pioneering journey, we have concrete data on what lies beyond the heliosphere, that vast bubble of charged particles created by the Sun. What we thought was an empty, hostile void turns out to be teeming with activity, and the discoveries continue to surprise. For instance, Voyager 1's passage through the heliopause, the boundary where the Sun's solar wind pressure is balanced by the pressure of interstellar space, marked an event that scientists had been eagerly anticipating for years. The data received at that point revealed that the transition from solar wind to interstellar space is not a simple one. The process is chaotic, with fluctuations in plasma density and changes in magnetic fields that scientists had never anticipated. These findings suggest that the heliopause is not a clear-cut, neatly defined boundary, but rather a complex and ever-changing region that scientists are still struggling to fully comprehend. Moreover, Voyager's ability to study the interstellar medium, the sparse matter that exists between stars, has led to fascinating revelations. For one, the density of this medium is far higher than scientists had expected, and the interstellar dust is not as diffuse as they had imagined. Voyager 1's plasma wave instrument has detected these particles, offering insight into the nature of this distant, largely unexplored environment. These discoveries could ultimately help researchers understand how stars, planets, and even life itself might emerge in other parts of the galaxy. The mysteries Voyager continues to unravel go beyond the interstellar medium and into the magnetic field lines that shape the cosmos. One of the more curious findings of the Voyager spacecraft is the magnetic field behavior at the edge of the solar system. Rather than simply flipping or reversing as anticipated, the magnetic field seems to be draped over the heliopause and interstellar space in a more complex fashion. This unexpected result challenges existing models of how solar and galactic magnetic fields interact. It raises the possibility of unknown mechanisms at work, influencing the dynamics of interstellar space in ways we have yet to understand. The way these magnetic fields behave could have far-reaching implications for how we think about space weather, cosmic radiation, and even the broader structure of the galaxy. While these discoveries have been groundbreaking, there's also something deeply humbling about the mission. Voyager was not designed with the intent to be a long-term space exploration probe. It was designed with a limited lifespan, meant to explore the outer reaches of the solar system, make flybys of Jupiter and Saturn, and capture images of distant planets. The fact that it has continued to function so long after that mission was completed is a testament to the ingenuity and vision of the scientists and engineers who built it. However, despite the spacecraft's incredible achievements, the journey is far from over. Voyager the 1st and the 2nd of May no longer be able to send back images of distant planets or capture new data from our solar system's far reaches, but they will continue to provide crucial information about the very nature of space itself. Their legacy will be remembered not only for what they taught us about the universe, but also for the potential they unlock for future missions that will venture even further. In a way, the most profound discovery that Voyager has made at the edge of the solar system is not a physical one at all. Rather, it is a philosophical realization. Voyager has shown humanity that even in the darkest, most distant corners of space, there is still much to learn. It reminds us that the universe is vast, mysterious, and full of untapped knowledge. It challenges us to look beyond our home planet and consider the possibility that we are not alone in the cosmos. The scientific community has already begun planning future missions to continue what Voyager started. Projects like the New Horizons mission, which recently flew by Pluto, and the proposed Interstellar probe are direct descendants of the Voyager legacy. These missions aim to venture even further into interstellar space, bringing us closer to understanding the true nature of our universe. But while they may one day surpass Voyager's physical distance, they will never quite surpass the profound sense of wonder that Voyager has instilled in humanity. For those who have followed the mission over the years, there is a deep sense of respect and awe. Voyager's discoveries have rewritten textbooks, expanded our understanding of the universe, and inspired countless people to dream of the stars. The mission has proven that, no matter how far we travel, the quest for knowledge has no limits. As we continue to reflect on the profound discoveries made by the Voyager spacecraft, we must also recognize the essential role of exploration in our human story. Voyager's journey has shown us that, though we may feel small and insignificant in the face of the vast cosmos, we have the capacity for greatness. By venturing into the unknown, we have taken our first tentative steps into the larger universe that awaits us. And though Voyager's journey may eventually come to an end, the questions it has raised will persist, beckoning future generations to follow in its path and unlock the secrets of the cosmos. We can only imagine what future civilizations, either human or alien, might one day discover about the legacy of Voyager. In the vast expanse of time and space, the spacecraft will continue its journey long after humanity itself may have faded into history. Its golden record, containing the sounds and sights of Earth, may one day be found by beings who will wonder about the creatures who sent it and the world they called home. And as they listen to the messages from Earth, the songs, the greetings, the laughter, they may come to understand that, in the end, it was curiosity, the desire to know, that defined us. It is a humbling thought that our very presence, our exploration of the stars, could be a message to the universe, one that transcends time, space, and the limitations of our brief existence. Voyager, like all great acts of exploration, represents not just a scientific achievement, but a piece of our shared humanity, our eternal quest to reach out, to connect, and to understand. As Voyager's journey continues to unfold beyond the boundaries of our solar system, we are confronted with a tantalizing notion that we may be on the verge of discovering something far more profound than we could have ever anticipated. The spacecraft's ongoing mission is not merely about recording data and cataloging phenomena. It is a silent, yet resolute, attempt to answer the deepest questions humanity has about the cosmos, and perhaps, our place within it. The sheer scale of the Voyager mission has always been a source of awe. As we think about the distances Voyager 1 and 2 have traveled, over 14 billion miles from Earth and counting, it's impossible not to be struck by the vast emptiness that lies between us and them. This emptiness, often imagined as a void, is anything but. It is teeming with unknowns, waiting to be explored. Voyager, in its unrelenting march toward the interstellar frontier, has become an emissary of humankind's eternal curiosity, but also a symbol of hope, a reminder that our pursuit of knowledge will continue, no matter how long it takes. And yet, even as we celebrate these achievements, there are moments of reflection that arise. What lies beyond the point where Voyager currently resides? What other mysteries lie hidden in the interstellar abyss? To answer these questions, it's not enough to simply look at the data the spacecraft has returned. We must ask ourselves what it means for humanity to embark on such an audacious journey. For example, when Voyager crossed the heliopause, it essentially entered a region that humans had never ventured into before. The spacecraft has become our eyes, ears, and senses in an area of space that we only dreamed of exploring. The data gathered from this passage reveals far more than the physical attributes of the environment. It speaks to the unknown forces at work in the universe, forces that shape not only the space between stars, but the very structure of matter itself. The arrival at the boundary of the heliosphere did not mark the end of the discoveries, but rather the beginning of a new chapter in our understanding of the universe. The density of the interstellar medium, measured by Voyager 1, was significantly greater than anticipated. This discovery has profound implications for our understanding of how stars and planetary systems form and evolve. It also raises questions about the role this medium plays in the galactic ecosystem, what it means for the birth of new stars, the migration of cosmic dust, and even the formation of new life in distant corners of the galaxy. One of the most perplexing discoveries Voyager made was related to the cosmic rays it detected as it journeyed deeper into interstellar space. These high-energy particles, originating from outside the solar system, are crucial to our understanding of the universe's origins and evolution. What surprised scientists, however, was the consistency of these cosmic ray measurements. They seem to indicate that the solar system's magnetic field is far more influential in shaping cosmic radiation than was originally believed. This discovery led to a paradigm shift in the study of cosmic rays, highlighting the complexity of the forces that shape space itself. Voyager's journey also revealed new insights into the Sun's role in the larger galactic system. For years, scientists had assumed that the Sun's influence gradually waned as one traveled farther from the solar system, giving way to the forces of the interstellar medium. What Voyager's data indicated, however, is that the Sun's magnetic field extends much farther than anyone had expected. In fact, it plays a critical role in defining the shape and dynamics of the heliosphere. This has implications for our understanding of how solar activity, such as solar winds and magnetic storms, influences the broader galactic environment, and even the potential habitability of exoplanets orbiting distant stars. The insights Voyager has provided about the Sun's magnetic field will likely inform future space exploration missions. For example, understanding the nature of solar winds and magnetic fields at the edges of the solar system is essential for planning missions to explore the outer planets, moons, and beyond. As space agencies look to send more probes into deep space, the knowledge gleaned from Voyager will help them navigate the challenges posed by the solar wind, cosmic rays, and other unknown factors in interstellar space. Another surprising discovery was Voyager's detection of fluctuating plasma densities at the outer edges of the solar system. In the past, scientists had assumed that the plasma in the outer reaches of the heliosphere would gradually become more diffuse and homogeneous as it extended outward into the interstellar medium. However, the spacecraft's instruments revealed highly variable plasma densities, raising new questions about the structure of the solar wind and its interaction with interstellar space. This observation is critical because it suggests that the boundary between the solar wind and the interstellar medium is not as clear-cut as previously thought. Instead, this zone is characterized by turbulent and dynamic interactions that can't be fully captured by traditional models of space physics. This insight has opened up new avenues for researchers to investigate the forces at play in the outer solar system and beyond, leading to potential breakthroughs in understanding the nature of plasma, magnetic fields, and the behavior of matter in extreme conditions. Perhaps one of the most profound discoveries Voyager has made is related to the concept of time. In 1977, when the spacecraft were launched, humanity could only dream of venturing beyond the solar system. But now, more than 4 decades later, Voyager 1 has become the first human-made object to enter interstellar space. The notion that this tiny probe, no larger than a school bus, is now traveling in the vastness of space, carrying the echoes of humanity's existence, is both humbling and inspiring. The data it continues to transmit reminds us that time, in the grand cosmic scale, is fluid. What seems like an eternity to us is just a fraction of a moment in the history of the universe. The golden record, which Voyager carries, represents another profound realization, that, in the grand expanse of space, we are not alone. The golden record contains sounds and images that describe the diversity and richness of life on Earth, offering a message to any possible civilizations that may one day find it. While the chances of this record ever being discovered by another intelligent species are astronomically small, the very act of sending it into space speaks to a fundamental aspect of human nature, our desire to connect, to share, and to leave a lasting mark on the cosmos. For scientists, the data that Voyager continues to send back is invaluable. It's a treasure trove of information that allows us to better understand the solar system, the interstellar medium, and the fundamental forces that govern the universe. It offers insights into how stars, planets, and galaxies form and evolve, and how the forces of gravity, electromagnetism, and nuclear energy interact in the vast, cold expanse of space. Yet, even as we learn from Voyager's findings, we are left with a sense of mystery. The spacecraft's journey is not just about collecting data, it's about the questions that remain unanswered. What lies beyond the interstellar medium? What other anomalies and phenomena will Voyager encounter as it continues its journey into the unknown? How does this knowledge reshape our understanding of the universe and our place within it? These questions remind us that space exploration is not merely about discovery. It is a journey of constant wonder, of seeking answers while embracing the unknown. Voyager's legacy is not just in the data it has provided, but in the sense of awe it continues to inspire. It shows us that, no matter how far we travel, there will always be more to learn, more to discover, and more to wonder about. And so, Voyager continues its journey, traveling farther into the dark abyss of interstellar space, sending back data that will guide and inspire future generations of explorers. As we look to the stars, we are reminded that humanity's quest for knowledge is boundless, and that the mysteries of the universe, whether they lie at the edge of our solar system or in the far reaches of the cosmos, are waiting for us to uncover them. As Voyager 1 and 2 press forward into uncharted territories, they remain the only emissaries of Earth in the infinite void of space. Their continuing exploration of interstellar space has not only expanded our scientific knowledge, but also highlighted the profound human drive to push beyond the limits of what we know. These two spacecraft, which have traveled farther than any other human-made objects, are not simply machines carrying data. They are extensions of our curiosity, carrying with them our hopes, dreams, and ambitions. The findings they return offer glimpses into a universe that is far more complex and mysterious than we could have ever imagined. Voyager 1's momentous crossing into interstellar space, a place beyond the influence of our sun's magnetic field, marked a milestone in the history of space exploration. But as it continues to traverse this vast, unknown realm, Voyager has begun to reveal just how little we truly understand about the universe outside our solar system. Each new data point received from Voyager is a testament to the unexpected nature of space and the immense challenges that remain in understanding its deepest secrets. One of the most fascinating discoveries Voyager has made during its time in interstellar space involves the behavior of the magnetic fields outside the solar system. When Voyager 1 crossed the boundary of the heliosphere, scientists were able to observe how the sun's magnetic field interacted with the interstellar medium. The solar wind, which had previously carried the sun's magnetic influence outward, slowed down and became increasingly turbulent as it reached the boundary, merging with the galactic wind that pervades the space between stars. Voyager's instruments measured the fluctuations of this interstellar magnetic field, revealing how it shaped the environment outside the solar system. This discovery opens the door to new insights about the nature of magnetic fields in interstellar space, and how they may influence star formation, the development of planetary systems, and the behavior of cosmic rays. Magnetic fields in space, often invisible to the naked eye, play a significant role in shaping the dynamics of galaxies, stars, and even the vast voids between them. Voyager's data has shown us that these magnetic fields are far more dynamic and complex than we once thought, and they may hold crucial clues to the underlying processes that govern the universe. In addition to magnetic fields, Voyager has made another striking observation: the unexpected presence of cosmic dust particles in the region beyond the heliopause. For years, scientists had assumed that the concentration of cosmic dust would decrease as one moved farther from the solar system. However, the Voyager spacecraft detected high levels of dust in the interstellar medium. This discovery is important for a number of reasons. Not only does it challenge our assumptions about the distribution of cosmic dust in the galaxy, but it also helps us understand how stars and planetary systems form. Cosmic dust, though seemingly inconspicuous, plays a vital role in the evolution of the universe. These tiny particles are the building blocks of stars, planets, and other celestial bodies. The fact that Voyager detected a higher-than-expected concentration of dust in interstellar space suggests that the material from which stars and planets are born is much more widespread than previously realized. This discovery could alter our understanding of star formation, as well as the process by which planets and other solid bodies come into existence. Another remarkable discovery Voyager made in the vast reaches of space was related to the charged particles that permeate the interstellar medium. When Voyager 1 crossed the boundary of the heliopause, its instruments detected an increase in the levels of cosmic rays, high-energy particles originating from distant stars and supernovae. These cosmic rays, which bombard planets and other celestial bodies, have long been a subject of fascination for scientists. What Voyager's observations revealed, however, was that the intensity and composition of cosmic rays in interstellar space were much more complex than scientists had imagined. The spacecraft detected changes in the energy spectrum of these particles as they moved farther from the solar system. The data also showed that the galactic cosmic rays had different sources and behaviors depending on where they originated in the galaxy. This discovery could have profound implications for our understanding of the processes that govern the formation and behavior of cosmic rays, as well as their role in the overall dynamics of the Milky Way. This new understanding of cosmic rays also raises intriguing questions about the impact they may have on future space exploration. If these particles are as widespread and as energetic as Voyager's data suggests, they could pose a significant threat to astronauts and spacecraft traveling beyond the protective shield of Earth's magnetic field. Understanding the behavior of cosmic rays is essential for ensuring the safety of long-term space missions, particularly those aimed at exploring Mars, asteroids, and beyond. The discovery of cosmic rays and their varied sources adds another layer of mystery to the interstellar medium, and it further underscores the complexity of the environment that Voyager is currently exploring. As we continue to learn more about these particles, we may uncover new insights into the structure of the galaxy, the forces at work within it, and the potential for life to exist in other parts of the universe. The fact that Voyager continues to send back valuable data, despite being so far from Earth, is a testament to the ingenuity and resilience of the engineers and scientists behind the mission. Voyager's instruments, designed to operate in the harshest of environments, continue to provide groundbreaking insights into the nature of space, even as the spacecraft grows increasingly distant from our home planet. As Voyager 1 continues to transmit data from over 14 billion miles away, it serves as a reminder of the incredible lengths to which humanity will go in the pursuit of knowledge. One of the most poignant aspects of Voyager's mission is the way it encapsulates the spirit of human exploration. The Golden Record, a message intended to be heard by any intelligent beings that might one day find it, represents a profound statement about humanity's desire to connect with the greater universe. The record contains sounds and images that describe the diversity of life on Earth, from the songs of whales to the greetings in various languages. It is a snapshot of our world, frozen in time, sent into space in the hopes that it might someday be discovered. The Golden Record is not just a message to potential extraterrestrial civilizations, but also a message to ourselves. It serves as a reminder that, despite our differences, we are all part of the same planet, and that our curiosity about the universe is a shared human endeavor. The Voyager spacecraft, now venturing into the great unknown, carries with it the hopes and dreams of all of humanity, offering a glimpse into what we might one day learn about the cosmos. As Voyager continues its journey, we are reminded that space exploration is not just about gathering data. It is about pushing the boundaries of what we know and seeking answers to questions that have long captivated our imaginations. What lies beyond the boundaries of our solar system? What mysteries are hidden in the dark recesses of the galaxy? And perhaps most profoundly, are we truly alone in the vast expanse of space? These questions will continue to drive humanity's exploration of the cosmos for generations to come. Voyager's discoveries have already reshaped our understanding of the universe, but there is still much more to learn. As we await the next revelations from this incredible mission, we are reminded that the pursuit of knowledge is a journey that knows no end. The universe is vast, and there is always more to discover, and with each new discovery, we take one step closer to understanding the deeper truths that lie at the heart of existence. As Voyager 1 and 2 continue their journey, the discoveries they make offer insights into not only the cosmic environment, but also humanity's place in the grand tapestry of the universe. The deeper we venture into the void, the more we realize how much remains hidden, yet how connected we are to the cosmic forces shaping the universe. These spacecraft, now traveling beyond the reach of the sun's influence, are more than just scientific instruments. They have become symbols of exploration, curiosity, and human ambition. Their data continues to challenge our assumptions and expand our understanding of the universe, revealing its astonishing complexity. One of the most intriguing aspects of Voyager's ongoing mission is the way it has reshaped our understanding of the boundary between the solar system and interstellar space. The moment Voyager 1 crossed the heliopause, the outermost edge of the solar system, it began transmitting data that has provided valuable insights into the nature of the interstellar medium. Scientists had long theorized about what this boundary would be like, but no one could have anticipated the surprising complexity of the phenomena Voyager would observe. For example, when Voyager crossed into interstellar space, scientists had expected the solar wind, the stream of charged particles emitted by the sun, to gradually fade away, being replaced by the galactic wind. What Voyager actually observed was a complex interaction between the two forces, with the solar wind slowing down and compressing as it collided with the interstellar medium, creating a turbulent environment. The spacecraft detected a range of fluctuations in the magnetic field, as well as significant changes in the density and temperature of particles in this region. These findings challenged our earlier models of how solar and galactic winds interact, showing that the boundary between the heliosphere and interstellar space is far more dynamic than anyone had previously imagined. In addition to the magnetic field observations, Voyager also provided crucial data about the behavior of plasma in the outer reaches of the solar system. Plasma, the fourth state of matter, is a highly ionized gas that makes up much of the universe's visible matter. In the regions beyond the heliosphere, Voyager has observed how this plasma behaves differently from what we observe in the Sun's vicinity. The plasma density and temperature in interstellar space vary significantly from that found within the solar system, with the spacecraft measuring a notable increase in density once it crossed the boundary into the interstellar medium. These observations suggest that the conditions in interstellar space are not as uniform as once thought, and that there may be variations in plasma behavior across different regions of the galaxy. This opens up new possibilities for understanding the processes at work in the broader cosmos and how stars and galaxies form and evolve. Voyager's data on plasma density and temperature is also crucial for understanding the dynamics of space weather. Space weather, driven by solar activity such as coronal mass ejections, CMEs, and solar flares, can have a profound impact on Earth's magnetic field and atmosphere. As Voyager continues to send back data, it helps scientists better predict space weather events that could affect not only our planet but also spacecraft traveling through the solar system and beyond. The spacecraft's observations provide a unique opportunity to study space weather in a region that is unaffected by the direct influence of the Sun, offering a baseline for understanding how cosmic weather operates in the larger context of the galaxy. The interaction between the solar wind and the interstellar medium is not the only surprising discovery Voyager has made in the vast expanse of space. The spacecraft has also been instrumental in uncovering the characteristics of cosmic rays. These high-energy particles, which originate from supernovae and other violent cosmic events, have long been a subject of intense study. Voyager 1's instruments have measured the intensity and composition of cosmic rays in a way that was previously impossible. As the spacecraft moved beyond the influence of the solar wind, it began detecting a greater intensity of cosmic rays, providing insights into the nature of these particles and their sources. What is particularly fascinating about these findings is the variability of cosmic rays across different regions of space. Voyager's data suggests that the intensity of cosmic rays fluctuates depending on the position of the spacecraft, which could be a result of varying levels of radiation in different parts of the galaxy. This discovery opens up a new avenue for studying the movement and behavior of cosmic rays, and may help scientists understand the sources of these particles, which could, in turn, provide insights into the mechanisms of supernovae, black holes, and other energetic cosmic events. Voyager's findings also raise intriguing questions about the potential effects of cosmic radiation on future space exploration. While the data provided by Voyager has greatly expanded our understanding of cosmic rays, it has also highlighted the dangers posed by these high-energy particles. For future astronauts traveling to destinations like Mars or beyond, understanding and mitigating the effects of cosmic radiation will be critical. Voyager's observations are helping scientists develop better models of radiation exposure and designing new protective measures for spacecraft and astronauts. This information could be key to ensuring the safety of long-duration space missions and may play a pivotal role in humanity's quest to explore the farther reaches of the solar system and beyond. Another captivating discovery Voyager made in interstellar space is the detection of cosmic dust. Cosmic dust particles are the tiny, microscopic remnants of stars and other celestial bodies that have exploded or disintegrated. These particles, though tiny, are incredibly important because they form the building blocks for the formation of new stars, planets, and other structures in the universe. Prior to Voyager's entry into interstellar space, scientists had assumed that cosmic dust would become less dense as one moved farther from the solar system. However, Voyager's instruments detected a surprising amount of dust in the outer reaches of space, revealing that the distribution of cosmic dust is far more complex than previously thought. The presence of cosmic dust in interstellar space has significant implications for our understanding of star formation and the processes that shape galaxies. Dust particles are integral to the formation of molecular clouds, where new stars are born. Voyager's observations suggest that the materials necessary for star and planet formation are more widely distributed across the galaxy than once thought. This could change our understanding of how stars and planetary systems form, and may even have implications for the search for extraterrestrial life. If the building blocks for life are more widespread than previously realized, it may increase the likelihood that life exists elsewhere in the universe. In addition to these remarkable discoveries, Voyager's journey has also provided us with a broader perspective on our place in the cosmos. As the spacecraft continues to travel farther from Earth, it serves as a constant reminder of the vastness of space and the limits of human understanding. The images it has sent back of our solar system, particularly the famous pale blue dot photograph taken by Voyager 1 in 1990, have become iconic symbols of the fragility and interconnectedness of life on Earth. In that photograph, Earth is a tiny speck in the vast expanse of space, a poignant reminder of how small and fragile our planet is in the grand scheme of the universe. The image, taken from a distance of over 3.7 billion miles, encapsulates the essence of our existence, a small, blue dot in the infinite darkness of space. The significance of this photograph is not lost on us. It serves as a humbling reminder that, despite our technological advancements and our ability to explore the far reaches of space, we are still bound to the same fragile planet. Voyager's journey is a testament to humanity's desire to explore and understand the cosmos, but it also underscores the need for us to protect our home, Earth. The knowledge gained from this mission will not only expand our understanding of the universe but will also help us safeguard our future as we continue to venture into the stars. The discoveries made by Voyager, however, are not just confined to scientific journals and technical reports. They have sparked the imaginations of people around the world, inspiring a new generation of explorers, scientists, and dreamers. As Voyager moves further away, it is not just exploring space, it is fostering a sense of wonder and possibility that transcends cultures and generations. The spacecraft's mission is a testament to the power of human curiosity and the pursuit of knowledge. Voyager's discoveries are just the beginning. As it continues its journey into the unknown, we can only speculate about what future revelations lie ahead. Perhaps one day, Voyager will send back data that will completely change our understanding of the universe. Or perhaps the spacecraft will continue to operate for many years, silently transmitting data about the vast, uncharted regions of space. Whatever the future holds, one thing is certain: Voyager's legacy will continue to shape our understanding of the cosmos for generations to come. As we look to the future, we must remember that space is not just an empty void, it is a vast, mysterious realm waiting to be explored. As Voyager continues to traverse the interstellar medium, we are reminded of the enormity of its journey. Even though Voyager 1 and 2 have long since passed the furthest points of human-made exploration, they continue to operate beyond the edge of our solar system, each day adding new pieces to the puzzle of our cosmic understanding. Their long-lasting missions have offered humanity a rare glimpse into the wilderness of space, where the laws of physics govern everything, from cosmic radiation to the interstellar medium that seems to stretch into infinity. As the two spacecraft venture farther into the void, one of the questions on many scientists' minds is how long their instruments will continue to function. Currently, both Voyager 1 and Voyager 2 are powered by nuclear fuel, specifically radioisotope thermoelectric generators, RTGs, which convert the heat from the natural decay of plutonium-238 into electricity. This power source, while incredibly reliable, is not infinite. Over time, the amount of energy the RTGs can produce diminishes, and the spacecraft's instruments slowly begin to lose their ability to function. However, despite this gradual decline in power, both spacecraft are still operational, sending back valuable data from the far reaches of the solar system. In 2025, Voyager 1 is expected to lose its ability to communicate with Earth, as its RTG will no longer provide enough power to transmit data back. However, even after communication ceases, both spacecraft will continue their eternal voyage through the galaxy, carrying with them the golden records that were designed to tell any potential extraterrestrial life about the human species. These records, which include sounds and images from Earth, will continue to exist as the only remaining artifact of human civilization long after our planet may have changed or even disappeared. The Voyager mission, in many ways, represents the lasting legacy of humanity's curiosity, ambition, and desire to understand the cosmos. Voyager's golden record is, in a sense, a snapshot of the world at a particular moment in time, a symbolic offering to the universe. The contents of the record are deliberately diverse, capturing the essence of human culture, music, and achievements. These records are expected to be carried for billions of years, drifting through space in the hope that someday, some civilization, far beyond our reach, might come across them. The idea that the Voyager spacecraft may one day encounter extraterrestrial intelligence is, of course, a long shot, but it is a possibility that gives the mission its profound significance. The golden records embody the human spirit, curious, hopeful, and determined to leave a mark in the universe. While the golden record itself may never be found, the discoveries Voyager has made thus far have already made a profound impact on our understanding of the universe. Voyager has provided the most detailed observations of the outer planets in our solar system, but its impact goes far beyond that. The spacecraft's long-term observations of the solar wind, magnetic fields, cosmic rays, and plasma density have opened new avenues of research into the nature of space weather and the interstellar medium. Voyager's legacy, in this sense, is not just the data it has already provided, but the many more questions it has raised for future generations of scientists to answer. In the years to come, Voyager's data will continue to shape the fields of astrophysics and space exploration. The spacecraft's observations are not just limited to the interstellar medium and the outer solar system. They are part of a broader effort to understand the forces at work throughout the universe. One of the most exciting prospects is that the data from Voyager may provide clues about the larger structure of the Milky Way galaxy and the dynamics of the intergalactic medium. It may also offer insights into the mysteries of dark matter and dark energy, two of the most elusive phenomena in modern physics. While these ideas are still far from being fully understood, Voyager's findings may provide the first steps toward unraveling these cosmic puzzles. Another key discovery made by Voyager concerns the heliosphere, the bubble of charged particles that the Sun's solar wind creates around the solar system. The spacecraft's measurements at the edge of the solar system have revealed that the heliosphere is not as uniform as once thought. The shape of the heliosphere, which was once assumed to be spherical, appears to be more comet-shaped, with the tail extending far beyond the orbit of Pluto. This finding challenges earlier models of the solar wind's interaction with the interstellar medium, suggesting that the forces at play in this region of space are much more complex than previously understood. The fact that Voyager has provided these revelations from such a distant point in space demonstrates the profound potential of human exploration. Even though the spacecraft are now separated by billions of kilometers from Earth, the data they continue to transmit paints a clearer picture of the fundamental processes shaping our solar system, our galaxy, and the universe as a whole. These findings, though incremental, are part of a larger puzzle that will take decades, if not centuries, to fully solve. However, Voyager has already contributed invaluable pieces to this puzzle, shaping the direction of scientific inquiry for years to come. In addition to these groundbreaking discoveries, Voyager has also provided a wealth of data about the solar system's outermost planets. When Voyager 2 made its historic flyby of Uranus in 1986, it became the first spacecraft to study this distant world in detail. It revealed the planet's unusual tilt and its system of rings, as well as the presence of large, icy moons like Miranda and Ariel. Voyager 2's flyby of Neptune in 1989 provided the first close-up images of the planet and its largest moon, Triton, which was found to have geysers erupting from its surface, suggesting the possibility of an underground ocean. These discoveries added new layers to our understanding of the outer solar system and raised important questions about the nature of icy bodies in the outer reaches of the solar system. Meanwhile, Voyager 1, which took its iconic image of Earth as the pale blue dot, has provided us with unique insights into the outermost reaches of the solar system, including the discovery of the heliopause, the boundary between the solar wind and the interstellar medium. This discovery, along with others, has changed the way we think about our solar system's place in the galaxy, and the Voyager spacecraft continue to send back valuable data that is helping us better understand the nature of space itself. As the spacecraft move farther into the unknown, the possibilities for new discoveries remain endless. The great achievement of Voyager is not just its ability to send back data from such a remote location, but the fact that it has opened new frontiers in space science that will continue to guide and inspire future generations of explorers. Whether or not the spacecraft ever encounter intelligent life or are ever found by future civilizations, the mission's legacy will endure as a testament to humanity's desire to explore, understand, and connect with the cosmos. And, as long as Voyager's instruments continue to function, it will be sending back data that will help scientists further unlock the mysteries of space, revolutionizing our understanding of the universe in ways we cannot yet imagine. The Voyager spacecraft, in their quiet voyage across the galaxy, remind us that space is not an empty void, but a dynamic, ever-evolving region of energy, matter, and force. As the spacecraft continue their journey through the stars, they serve as both messengers and witnesses to the vastness of the cosmos. We may not fully understand what they have uncovered yet, but their continued operation will undoubtedly change the way we see the universe and our place within it for generations to come. As the Voyager spacecraft continue their journey into interstellar space, the data they continue to send back holds immense value for scientists and astronomers. Their mission is far from over, even though these two intrepid explorers are now over 40 years old. Every day that passes, they continue to transmit groundbreaking information that helps shape our understanding of the universe. In the years that have passed since their launch, both Voyager 1 and Voyager 2 have taken on a much greater significance, evolving from mere exploratory spacecraft into symbols of human curiosity and ingenuity. One of the most remarkable aspects of the Voyager mission is its longevity. Both spacecraft were never intended to operate for as long as they have. Initially, their primary mission was to explore the outer planets of our solar system. Voyager 1 was tasked with flying past Jupiter and Saturn, while Voyager 2 was given the more ambitious mission of visiting all four outer planets: Jupiter, Saturn, Uranus, and Neptune. Once the primary objectives were completed, the mission was meant to be terminated, and the spacecraft would be sent into deep space with no further communication. But against all odds, both spacecraft continued to function well beyond their expected lifespans, and their findings continue to surprise scientists. The most extraordinary discovery made by Voyager 1 came when it crossed the threshold of the heliopause, the boundary marking the end of the Sun's influence over the surrounding space. As it crossed this line in 2012, Voyager 1 officially became the first human-made object to enter interstellar space. This milestone was a momentous achievement in the history of space exploration. It not only marked the end of the solar system as we know it, but also began a new era in understanding the properties of space beyond the Sun's protective bubble. The data that Voyager 1 provided after crossing the heliopause was groundbreaking. Scientists discovered that the nature of cosmic radiation in interstellar space was vastly different from what had been previously anticipated. Prior to Voyager's arrival at the edge of the solar system, it was believed that the cosmic rays in the interstellar medium would be relatively stable. However, as Voyager 1 transmitted its findings, it became clear that the cosmic radiation levels outside the solar system were much more intense than expected. This finding has significant implications for our understanding of the hazards that await any future interstellar travelers. Moreover, Voyager 1 has given scientists new insights into the structure of the interstellar medium, the vast region of gas and dust that permeates space between stars. By analyzing the way that the spacecraft interacts with this medium, scientists have been able to piece together information about the density and composition of the material that fills the space between the stars. This discovery has far-reaching implications for understanding how stars and galaxies form, evolve, and interact with one another. In addition to its scientific contributions, the Voyager mission also serves as an enduring message to the cosmos. The golden records, carried by both Voyager 1 and Voyager 2, serve as humanity's first attempt to reach out to the stars. These records contain a variety of sounds and images that represent the diversity of life and culture on Earth. They include music from different cultures and eras, greetings in 55 different languages, and even a selection of natural sounds from Earth, such as the sounds of thunder, birdsong, and whales. The golden record is a profound statement of human hope, curiosity, and the desire to make contact with intelligent life elsewhere in the universe. It is unlikely that anyone will ever encounter the Voyager spacecraft or the golden records. Even so, the idea that these messages will continue to travel through space for billions of years is deeply symbolic. It is a reminder that humanity's curiosity and quest for knowledge transcend the limits of time and space. As the spacecraft drift through the galaxy, they carry with them the essence of human civilization, a snapshot of our species at a moment in time. The golden records, though unlikely to ever be discovered by extraterrestrial life, represent humanity's hope that we are not alone in the universe, and that we are part of something much greater than ourselves. However, the legacy of the Voyager mission is not solely tied to its golden records or its groundbreaking discoveries about the solar system and interstellar space. The true significance of the Voyager spacecraft lies in the questions they have raised, questions that will continue to drive scientific exploration for generations to come. As we move further into the 21st century, the discoveries made by the Voyager spacecraft will continue to shape our understanding of the universe and the role that our solar system plays within it. For example, one of the lingering questions raised by the Voyager spacecraft involves the true nature of the boundaries of the solar system. The heliosphere, the bubble of charged particles created by the solar wind, extends far beyond the orbit of Pluto. However, scientists have yet to determine exactly where the solar system truly ends. Voyager 1 and 2 have given us the first clues about this boundary, but much remains to be learned. As the spacecraft travel farther from the Sun, they continue to send back data that will help us refine our models of the solar system's outer limits. Another area of research that has been greatly influenced by the Voyager mission is the study of cosmic radiation and the behavior of charged particles in space. Voyager 1's observations of the interstellar medium have helped scientists better understand the nature of cosmic rays and the impact that these high-energy particles can have on space exploration. The information gathered by Voyager is likely to be invaluable as we prepare for future missions to Mars and beyond. Understanding the effects of cosmic radiation on spacecraft and astronauts is a key concern for long-duration space travel, and the data from Voyager will undoubtedly help inform the design of future missions. In addition to these practical considerations, the Voyager mission has also raised more philosophical questions about the place of humanity in the universe. The golden records, for example, are a testament to our desire to communicate with other civilizations, but they also prompt deeper reflections on the nature of life in the cosmos. Are we truly alone in the universe, Or are there other intelligent civilizations out there waiting to be discovered? The Voyager spacecraft, though humble in their design, have become symbolic of humanity's ongoing search for answers to these existential questions. They remind us that, despite the vastness of space, we are not isolated in our quest for knowledge. The discoveries made by Voyager continue to inspire a sense of wonder and curiosity about the universe and our place within it. As the years pass, the Voyager spacecraft will continue to fade into the distant reaches of space, their power supplies dwindling and their instruments becoming silent. But even as their mission comes to a close, the legacy of the Voyager program will live on. The discoveries made by these two spacecraft have already reshaped our understanding of the solar system, the interstellar medium, and the fundamental processes that govern the universe. Their data will continue to be analyzed for decades, providing new insights into the mysteries of space. And the golden records, though unlikely to be found by extraterrestrial civilizations, will serve as a lasting testament to humanity's curiosity, creativity, and hope. The Voyager mission is, in many ways, the ultimate expression of human exploration. It is a journey that has taken us to the farthest reaches of the solar system and beyond, revealing secrets about the nature of space and our place in the cosmos. It is a mission that continues to inspire future generations of scientists, engineers, and dreamers, who will build upon the legacy of Voyager to continue exploring the universe and expanding the boundaries of human knowledge. As Voyager 1 and Voyager 2 continue their voyages into the great unknown, we can only imagine the discoveries yet to be made. The spacecraft may be long past the limits of the solar system, but their journey is far from over. Their legacy will endure, reminding us of the incredible potential of human curiosity and the unyielding drive to understand the universe. The legacy of Voyager 1 and Voyager 2, as they continue their journey far beyond the realms of our solar system, will undoubtedly shape the future of space exploration for centuries to come. The spacecraft, long after their final communication is lost, will remain symbols of humanity's unwavering drive to explore the vast, mysterious expanse of space. As they drift into the interstellar medium, they embody not just the triumphs of scientific ingenuity, but the essential curiosity that drives our species to look beyond our world and our solar system. One of the most remarkable aspects of the Voyager mission is its role in pushing the boundaries of human knowledge. When the spacecraft were launched in the 1970s, the furthest we had ever explored was the outer reaches of our solar system, with probes like Pioneer 10 and Pioneer 11, which had made brief forays into space beyond the planets. Voyager, however, was different. It was designed for more than just a flyby of distant planets. The scientific instruments aboard Voyager 1 and 2 were intended to send back data about the outer planets, but their capabilities far exceeded initial expectations, allowing them to continue to provide invaluable insights about the universe decades after their missions were supposed to end. In the early days, when Voyager 1 passed Jupiter in 1979 and Saturn in 1980, the spacecraft delivered stunning photographs and data that revolutionized our understanding of the outer solar system. These discoveries included the discovery of new moons orbiting Jupiter and Saturn, detailed imagery of the gas giants and their rings, and data about the composition and structure of the planets themselves. But these were only the beginning of what the Voyagers would uncover. Once their planetary mission was completed, Voyager 1 and 2 continued to send data back, extending the mission into a new phase that focused on the boundaries of our solar system and beyond. Voyager 1, now over 14 billion miles from Earth, entered interstellar space in 2012. It marked a major milestone in space exploration, becoming the first human-made object to leave the influence of the Sun's magnetic field. But this was not the end of its journey, far from it. As Voyager 1 crosses into the vast emptiness of interstellar space, it continues to send back vital data. For years after crossing the heliopause, scientists had hoped to receive more information from the spacecraft regarding its experience in the true frontier of space, beyond the protective influence of the Sun's magnetic bubble. The first set of surprising discoveries came from Voyager 1's interaction with cosmic rays. As it moved away from the Sun's radiation, scientists were surprised to find that the intensity of cosmic rays outside the solar system was much higher than expected. Cosmic rays, high-energy particles that originate from beyond our galaxy, pose a significant threat to both spacecraft and any future astronauts venturing into deep space. Voyager's sensors revealed the dramatic difference between the particle radiation inside the heliosphere and what lay beyond it. This discovery has profound implications for future interstellar travel, highlighting the potential hazards of deep space radiation that could harm both electronics and biological organisms. Further surprising findings emerged regarding the interstellar medium. Scientists had long speculated about the properties of the space between the stars, but the data collected by the Voyager spacecraft has proven more complex than anticipated. As Voyager 1 passed through the boundary into interstellar space, it began to measure the pressure of the gas and particles in the surrounding environment. These measurements have shown that the interstellar medium is denser than previously thought, and it interacts with the solar wind in ways that we are still trying to fully understand. The discovery of these intricacies has given us a much clearer picture of the invisible forces that govern the galaxy. In the years since Voyager 1 and 2 entered interstellar space, there has been much anticipation about what the spacecraft could reveal about the larger structure of the Milky Way. Even though the spacecraft have long since left the solar system, their instruments are still actively gathering data about the broader cosmic environment. This information is invaluable for understanding the structure of our galaxy, including the magnetic fields that permeate interstellar space. One of the key components of this research is the study of plasma waves. Voyager's plasma wave instrument continues to send back data about the density and behavior of ionized gas in the space between stars. These waves are crucial to understanding how energy and matter interact in the vast stretches of the cosmos. Moreover, the discovery of magnetic fields in the interstellar medium has raised new questions about the nature of space itself. Voyager's magnetometer has provided evidence of fluctuations in the magnetic field of the interstellar medium, suggesting that the Milky Way's magnetic field might be far more complex than previously believed. These fluctuations could help astronomers understand how cosmic rays are accelerated and how magnetic fields are generated and maintained in deep space. Yet, Voyager's contributions are not limited to understanding the physical properties of space. The spacecraft are also shedding light on the mysterious interactions between solar and cosmic phenomena. For instance, data from the Voyager probes has shown that the Sun's solar wind behaves differently outside the solar system than it does within the heliosphere. The solar wind's interaction with the surrounding interstellar material reveals a dynamic and constantly changing environment that scientists are still trying to decode. In addition to scientific discoveries, the Voyager mission has had a profound cultural and philosophical impact. The golden records carried by the spacecraft serve as humanity's first attempt to communicate with potential extraterrestrial civilizations. Though the likelihood of these records being found is infinitesimally small, their creation has sparked important discussions about humanity's place in the universe and the possibility of other intelligent life beyond our planet. The records are a bold statement of human curiosity and the desire to reach out across the stars, hoping to find someone, anyone, who might listen. The inclusion of a variety of sounds, images, and music on the record showcases the diversity of life and culture on Earth, offering a glimpse of our species at a particular moment in time. Even as the data from the Voyager spacecraft continues to provide crucial insights into the unknown, the golden records remain a powerful testament to the human spirit. They reflect a vision of hope, a message of peace, and an expression of our desire to share our existence with the cosmos. The very act of sending these records into space symbolizes humanity's eternal curiosity and the drive to explore and understand the universe. As the spacecraft drift farther from Earth, the question of whether anyone, or anything, will ever encounter the Voyagers becomes more pressing. The chances are slim that an alien civilization will discover the golden records or even detect the signals being sent back by the spacecraft. Still, the idea that they will continue their journey for billions of years is a powerful reminder of the far-reaching consequences of human exploration. Voyager's message will outlive us all. Its travels will continue long after Earth has faded into the distant past, carrying the echoes of human civilization far into the future. The Voyager spacecraft also serve as a reminder of the limitations of human knowledge and our eternal thirst for discovery. We may never fully comprehend the mysteries of the universe, But the journey of Voyager 1 and Voyager 2 shows us that the pursuit of knowledge is, in itself, one of humanity's greatest achievements. These spacecraft have not only expanded our understanding of space but have also inspired generations of scientists, engineers, and dreamers who will continue to explore and learn. As we look to the future of space exploration, the legacy of Voyager will continue to shape the way we approach our next steps into the stars. The lessons learned from these spacecraft, as well as the questions they have raised, will guide future missions and inform the design of new technologies that will help us reach even farther into the cosmos. The mission of Voyager serves as a testament to the power of curiosity, perseverance, and the human desire to push the boundaries of what we know. Voyager's discoveries have forever changed our understanding of space, and as the spacecraft continue their journey into the dark expanse of the interstellar medium, they will continue to inspire generations of explorers to come. The Voyager spacecraft, as they venture farther from our solar system, continue to provide us with profound insights not only about space but about our place within the vast expanse of the universe. As they move beyond the protective bubble of the Sun's influence, Voyager 1 and Voyager 2 are offering humanity an unprecedented opportunity to study the universe in ways previously unimaginable. These spacecraft have become time capsules, bearing witness to humanity's pioneering spirit, as they carry our legacy across interstellar space, beyond the farthest reaches of our Sun's grasp. What makes the Voyager mission even more remarkable is that, despite the vast distances involved, they continue to send data back to Earth. Both Voyager 1 and Voyager 2 were equipped with cutting-edge technology for their time, but even more incredibly, this technology has proven resilient and adaptable, allowing these spacecraft to operate well beyond their expected lifetimes. As of today, they are both functioning more than 40 years after their launch, far outliving their original mission timelines. The continued success of the Voyager probes is a result of both their design and the efforts of NASA's Deep Space Network, DSN, which has worked tirelessly to maintain communication with these distant travelers. The DSN's massive radio antennas, located in California, Spain, and Australia, are the lifeline between Earth and the Voyager spacecraft, allowing signals to be sent and received across interstellar distances. The signals are faint, and the communication time delay is significant. Messages that once took hours to send now take over 20 hours one way. Yet, the Voyager spacecraft still managed to send back invaluable data that helps scientists study the outermost regions of our solar system and the environment beyond. In the years since they entered interstellar space, Voyager 1 and 2 have become key instruments for measuring the behavior of particles, plasma, and magnetic fields in regions of space that were previously beyond our reach. One of the most astonishing aspects of their mission is the discovery of the cosmic boundaries that separate our solar system from the rest of the galaxy. Voyager 1, in particular, was the first spacecraft to cross the heliopause, the boundary where the Sun's solar wind slows down and is overtaken by the interstellar medium. This event was a milestone in space exploration, marking the point at which Voyager 1 officially left the bubble of influence created by the Sun and entered the vast, dark expanse of interstellar space. While the crossing of the heliopause itself was an incredible achievement, the data that Voyager 1 sent back in the wake of this momentous event proved even more groundbreaking. For instance, scientists were initially unsure about what the environment beyond the heliopause would be like. They expected to encounter a less turbulent, calmer region, but instead they found that the interstellar medium was filled with far more high-energy particles and magnetic disturbances than anticipated. These findings have provided new insights into the structure and behavior of the universe outside our solar system. One of the most fascinating pieces of data came from the spacecraft's observations of cosmic rays. Upon crossing the boundary into interstellar space, the intensity of these high-energy particles increased dramatically. Voyager 1's instruments were able to measure this increase, helping scientists better understand the composition and behavior of cosmic radiation and its interaction with our solar system. This information has critical implications for space exploration, especially for future missions that may involve human crews traveling beyond the protection of Earth's magnetosphere. The dangers of cosmic rays and their potential effects on human health are a key challenge that future space explorers will need to overcome. As Voyager 1 and 2 continue their lonely journeys through space, their instruments continue to collect data on the particles and energy fields that surround them. The plasma wave instruments on both spacecraft are providing valuable measurements of the density and composition of the interstellar plasma, which is crucial for understanding the broader structure of the galaxy. These measurements have confirmed that the solar wind, the stream of charged particles emitted by the Sun, does not extend forever. It interacts with the interstellar medium in a way that creates a boundary, marking the limit of the Sun's influence on space. This boundary, known as the heliopause, was not fully understood before the Voyager spacecraft ventured beyond it, and now, thanks to their data, scientists have a much clearer picture of how the solar wind behaves as it interacts with the rest of the galaxy. Voyager 2, which followed a different trajectory and was the first to encounter Uranus and Neptune, has also made its own set of remarkable discoveries. Even though it's not as far from Earth as Voyager 1, its data remains essential for our understanding of the outer reaches of the solar system and the interstellar medium. For example, the spacecraft's flybys of Neptune and Uranus provided invaluable insights into the composition and characteristics of these distant gas giants. These discoveries, in combination with the data sent back by Voyager 1, have given scientists an unprecedented view of the outermost reaches of our solar system, contributing to our knowledge of planets, moons, and other celestial bodies. Both spacecraft are also providing key data about magnetic fields beyond our solar system. The Voyager magnetometers have revealed more about the complex magnetic environment of the interstellar medium, offering insights into how these fields are shaped and how they interact with other forces in space. The data shows that magnetic fields in interstellar space are not uniform, and their behavior may differ significantly from the fields within our solar system. This discovery has led to a reevaluation of the magnetic models that we use to understand the behavior of space, including how magnetic fields are generated and sustained throughout the galaxy. Another aspect of the Voyager mission that continues to capture public imagination is the Golden Record, a message to potential extraterrestrial life. Each Voyager spacecraft carries a golden phonograph record that contains sounds and images intended to represent the diversity of life and culture on Earth. The inclusion of these records on the spacecraft was not just an afterthought but a carefully curated message, meant to serve as a representation of humanity to any intelligent life that might encounter it. It includes a range of sounds, from greetings in 55 different languages to music from various cultures, including Bach, Beethoven, and a traditional Peruvian pan flute piece. The Golden Records are one of the most iconic aspects of the Voyager mission and continue to be a source of fascination for many. They represent the hope that, someday someone, or something, will find them and learn about the civilization that created them. However, it's important to note that the chances of the Voyager spacecraft being discovered by extraterrestrial life are exceedingly slim. Even if they do eventually encounter alien civilizations, the records might remain unread, a silent testament to humanity's desire to reach out beyond the stars. While the likelihood of the Golden Records ever being discovered is remote, they are a symbol of humanity's deeper questions about the universe. What are the chances that we are alone in the cosmos? What would it mean for us to encounter another intelligent species? The records provide a glimpse into the human desire for connection, communication, and exploration. They remind us that, even though we are but a tiny part of an enormous universe, we still seek to understand our place within it. As the Voyager spacecraft continue their journey into the unknown, they will likely encounter many more surprises. The data they send back may reveal even more about the interstellar medium, cosmic radiation, and the nature of deep space. But one thing is certain: the legacy of the Voyager mission will continue to inspire and inform generations of scientists, explorers, and dreamers for many years to come. The work done by the Voyager spacecraft has reshaped our understanding of space, showing us that there is much more out there than we could have ever imagined. Each discovery made by these spacecraft challenges our assumptions, pushing the boundaries of human knowledge and sparking new questions about the universe. As we look toward the future of space exploration, we can only imagine what the next great discoveries will be, and how they will continue to push the boundaries of what we know about the cosmos. As Voyager 1 and 2 continue their odyssey through interstellar space, the mysteries that lie ahead remain largely unknown. Despite having already made numerous groundbreaking discoveries, the mission is far from over. One of the remarkable aspects of the Voyager spacecraft is that they are continuing to function well past their expected lifetimes, sending back data that helps scientists piece together the vast puzzle of the cosmos. Each day, their instruments continue to send information back to Earth, even as they travel farther from home, closer to the distant stars that will never be their final destination. The spacecraft's longevity is a testament to the foresight and engineering brilliance that went into their design. Their energy source, a radioactive power generator known as a radioisotope thermoelectric generator, RTG, has been designed to last for decades. Even as the power output of the RTGs decreases over time, the spacecraft's instruments have been strategically powered down to conserve energy, allowing the Voyagers to continue gathering and transmitting data for as long as possible. This longevity not only highlights the effectiveness of the spacecraft's design but also underscores the importance of foresight in planning space missions that will outlast the generations that launched them. The Voyager spacecraft were initially launched with the goal of exploring the outer planets of our solar system, but as their missions evolved, they became something far greater, pioneers on a journey to the stars. In their more than 4 decades of operation, they have revolutionized our understanding of space. They were the first spacecraft to give us close-up images of the gas giants, their moons, and the distant regions of the outer solar system. But it was their entry into interstellar space that has truly set them apart, revealing aspects of the universe that were previously unfathomable. One of the most astounding discoveries came when Voyager 1 crossed the heliopause and entered interstellar space. Before the spacecraft's encounter, scientists had little direct information about what lay beyond the influence of the Sun's solar wind. The area beyond the heliopause, called the interstellar medium, was a vast, largely unexplored region. What Voyager 1 found was a far more complex and dynamic environment than anyone had expected. The spacecraft encountered an increase in cosmic ray activity and found a greater density of particles than anticipated. This information has helped scientists refine models of the solar system's interactions with the interstellar medium, providing vital information about how stars like our Sun are embedded in the galaxy. The data from the Voyager spacecraft have also provided important insights into the behavior of the solar wind. For much of their missions, both Voyager 1 and 2 have been studying the flow of particles from the Sun as they interact with the rest of the galaxy. One of the key discoveries is that the solar wind does not continue indefinitely, but instead slows and eventually stops, creating a boundary known as the termination shock. Beyond this boundary, the solar wind's influence weakens, and the interstellar medium begins to dominate. Voyager's data has helped define the precise nature of this boundary, providing a better understanding of the Sun's influence on its surrounding environment and how it affects the broader galactic space. What makes the Voyager mission even more fascinating is the ability to detect phenomena that were once thought to be purely theoretical. One such phenomenon is the presence of interstellar magnetic fields. Before Voyager 1's historic crossing of the heliopause, the idea that magnetic fields could extend beyond the influence of the Sun seemed speculative. However, Voyager 1's magnetometer was able to measure the presence of these fields, confirming their existence. The discovery of interstellar magnetic fields has opened up new areas of research, particularly in understanding how these fields might influence the motion of cosmic particles and the evolution of galaxies. In addition to their observations of magnetic fields and solar wind, both Voyager spacecraft have continued to measure cosmic rays and plasma. As the spacecraft travel further into interstellar space, their instruments have detected an increase in the intensity of cosmic rays, high-energy particles that are the remnants of supernovae and other galactic events. These particles travel across the universe at nearly the speed of light, and their behavior can tell scientists a great deal about the structure of the galaxy. For example, the increase in cosmic ray intensity observed by Voyager 1 as it entered interstellar space suggests that the interstellar medium is far more turbulent and dynamic than scientists had previously realized. The unique data gathered by the Voyagers have provided valuable insights into the composition and behavior of the outer regions of our solar system. For example, Voyager 2's observations of the outermost planets, Uranus and Neptune, have reshaped our understanding of these distant worlds. Voyager 2's flyby of Uranus, the first and only such mission, revealed a planet with a tilted axis and a unique magnetic field. Similarly, Voyager 2's flyby of Neptune provided the first detailed images of its Great Dark Spot, a storm system similar to Jupiter's Great Red Spot. These discoveries have led to a reevaluation of our models of planetary formation and have raised new questions about the nature of the outer solar system. While these discoveries of our own solar system are significant, it is the Voyager's contributions to our understanding of space beyond our solar system that will have the most lasting impact. With each passing year, the spacecraft are providing humanity with invaluable data on the nature of interstellar space. This data will be critical for future missions, both robotic and human, that will venture into deeper parts of space. Scientists are already planning for the next generation of spacecraft that will continue the work begun by the Voyager probes. One of the most exciting possibilities for future missions is the study of exoplanets, planets orbiting stars outside our solar system. As the Voyager spacecraft continue their journey, they remain humanity's most distant emissaries in space. Their golden records, which contain sounds and images from Earth, serve as a symbolic representation of our desire to connect with the universe beyond our planet. While the likelihood of these records being discovered by an extraterrestrial civilization is remote, the very act of sending them represents humanity's deep-seated curiosity about the cosmos and our place within it. In the future, the Voyager spacecraft may continue to provide valuable data for many decades to come. However, as their power continues to wane and their instruments slowly shut down to conserve energy, the time will inevitably come when the spacecraft can no longer communicate with Earth. At that point, Voyager 1 and 2 will become silent travelers, drifting through the interstellar medium, carrying with them the memory of humanity's bold exploration of space. The Voyager missions are among the most successful space missions ever undertaken. They have taught us more about the outer planets and the boundary of our solar system than we ever thought possible. They have confirmed the existence of interstellar space, provided insights into the dynamics of the solar wind, and illuminated the strange and often mysterious behavior of cosmic radiation. The legacy of the Voyager spacecraft will continue to influence space exploration for many years to come, shaping our understanding of the cosmos and inspiring future generations to continue the journey of discovery. As we reflect on the accomplishments of the Voyager spacecraft, we must remember that their mission is not just about exploring the solar system or sending a message into deep space. It is a reminder of humanity's insatiable curiosity, our drive to explore the unknown, and our desire to understand the universe and our place within it. The Voyagers have opened the door to the stars, and it is now up to us to continue the exploration they have begun. As we reflect on the future of space exploration, it's impossible to overstate the significance of the Voyager spacecraft. Their legacy not only lies in the astounding discoveries they've made but in how they have shaped humanity's understanding of the cosmos. These spacecraft have shown us that even in the vast, seemingly empty void of space, there is so much more to learn, uncover, and explore. The further Voyager 1 and 2 travel, the more we learn about the nature of space itself, about the structure of our solar system, and even about the forces that govern our universe. The Voyager missions have also made an indelible impact on how we think about space exploration. They have pushed the boundaries of what is possible with technology, serving as a constant reminder that even in the most extreme conditions, human ingenuity can create machines that transcend expectations. What began as a mission to explore the outer planets of our solar system has become a monumental journey that is still providing invaluable scientific data. One of the remarkable aspects of the Voyager missions is that they continue to work, even after their expected lifetime has passed. Both spacecraft, which were launched in the late 1970s, have far outlasted the original mission designs, with Voyager 1 now over 23 billion kilometers from Earth. While their instruments have begun to degrade due to the lack of sufficient power, they are still sending back crucial data that continues to surprise scientists. The longevity of these spacecraft is a tribute to the brilliance of NASA's engineers, who designed the Voyager spacecraft with foresight and innovation that has allowed them to remain functional long beyond what was originally anticipated. In fact, the discovery that Voyager 1 had entered interstellar space was itself a landmark achievement in our understanding of the cosmos. Interstellar space is the vast, nearly empty region between stars, and before the Voyager spacecraft crossed into this unknown frontier, scientists had never directly measured conditions in this part of the universe. Voyager 1's data confirmed that the space beyond the heliopause, where the solar wind ceases to have any significant influence, was vastly different from the space closer to our Sun. The intensity of cosmic rays, the presence of magnetic fields, and the density of interstellar plasma provided insights into the interactions between the Sun and the broader galactic environment. Voyager 1's entry into interstellar space also provided a glimpse into the future of space exploration. As the spacecraft continues to journey farther from Earth, its sensors will continue to gather data that will inform scientists about the behavior of cosmic rays, the properties of the interstellar medium, and the dynamics of the local interstellar cloud. These insights are critical not just for understanding our solar system's relationship with the galaxy, but also for preparing for future space missions that will venture beyond the solar system. But the Voyager spacecraft's discoveries are not just confined to the realms of theoretical physics and astrophysics. They have also contributed significantly to our understanding of planetary systems. Both Voyager 1 and 2 flew by multiple planets during their journeys, offering us some of the most detailed images and data of distant planets and their moons. For example, Voyager 2's flybys of Uranus and Neptune revolutionized our understanding of these ice giants, revealing details about their atmospheres, magnetic fields, and ring systems that were previously unknown. Uranus, for instance, was found to have a unique axial tilt, which scientists believe was likely caused by a massive collision in its early history. The tilt of the planet's axis, combined with its peculiar magnetic field, provided new insights into the processes that govern planetary evolution. Voyager 2 also discovered several new moons orbiting Uranus, expanding our knowledge of the planet's complex system. Similarly, Voyager 2's encounter with Neptune revealed its Great Dark Spot, a storm system akin to Jupiter's Great Red Spot, and provided the first close-up views of the planet's moon Triton, which was found to have a geyser-like activity, suggesting it harbored some form of subsurface activity. These discoveries reshaped our understanding of the outer planets, showing that even distant and seemingly uninteresting worlds could contain mysteries that were worth exploring. Voyager 2's exploration of Neptune also underscored the importance of scientific missions to distant destinations in our solar system. While the spacecraft was on its way out of the solar system, it sent back data that would continue to inform planetary scientists for years, even decades, to come. Without these spacecraft, our understanding of the outer solar system would remain much more limited. Moreover, these missions taught scientists that we can still discover surprises in the universe, no matter how well we think we understand it. For example, the discovery of a previously unknown magnetic field around Jupiter's moon Ganymede by Voyager 1, or the data showing unexpected radiation belts at Saturn, highlighted how complex and unpredictable the nature of planetary systems can be. These findings suggested that there is still much to learn about the mechanics of planetary systems, particularly in the outer reaches of our solar system and beyond. The data from Voyager 1 and 2 continue to be crucial for astronomers and astrophysicists trying to unravel the mysteries of the universe. One of the key areas of focus is the study of the solar wind and its interactions with the interstellar medium. As Voyager 1 continues to move farther into interstellar space, it's providing scientists with new information about how the solar wind interacts with the local interstellar cloud, a structure of gas and dust that surrounds the solar system. These interactions help scientists understand the broader dynamics of star systems, such as the formation and evolution of the Sun and its relationship with the rest of the Milky Way galaxy. The observations made by Voyager 1 and 2 have also been instrumental in shaping our understanding of the cosmic ray environment. Cosmic rays, high-energy particles that come from outside our solar system, are an important part of astrophysical research, and the data from the Voyagers are helping scientists piece together the puzzle of where these particles come from, how they travel through the galaxy, and how they impact the environment around us. The data sent back by Voyager 1 has shown that the cosmic ray environment in interstellar space is much more intense than what we experience within the heliosphere, further deepening our understanding of the universe's most energetic particles. The legacy of the Voyager spacecraft is one of relentless curiosity, and it has opened up countless avenues of exploration that will keep scientists busy for generations to come. The knowledge these spacecraft have provided will inform not just space exploration but also a wide range of scientific fields, from planetary science to fundamental physics. Their discoveries have reshaped how we understand our solar system, the nature of stars, and the dynamic forces that shape the universe. Even as Voyager 1 and 2 continue their journeys farther from Earth, they remain the ultimate testament to human ingenuity and the unyielding desire to explore the cosmos. For future generations, the Voyager missions will remain a shining example of what humanity can achieve in the field of space exploration. They have demonstrated that there is no limit to what we can learn if we are willing to push the boundaries of our understanding and embark on bold missions to explore the unknown. As Voyager 1 and 2 continue their lonely journey into the depths of interstellar space, they will carry with them not only the spirit of exploration but also the legacy of human achievement in space. The exploration of the outer solar system and the journey into interstellar space has only just begun. Future missions will build upon the foundations laid by the Voyager spacecraft, expanding our understanding of the universe and our place within it. The discoveries made by Voyager 1 and 2 will continue to inspire future generations of explorers, scientists, and dreamers who look up at the stars and wonder what lies beyond the horizon. And as we move forward into the cosmos, we can only imagine what new and incredible discoveries await us in the vast and mysterious universe. As humanity's quest for knowledge continues, the Voyager spacecraft, long after their initial missions, are continuing to play a pivotal role in shaping our understanding of space. Despite the vast distances that separate us from these spacecraft, the data they continue to send back, even in their diminishing years, are more than enough to keep the scientific community captivated. Their findings have unlocked the door to a deeper comprehension of the environment of our solar system, the properties of interstellar space, and the behavior of cosmic rays, among many other fundamental phenomena. It's fascinating to think about how far these spacecraft have come since their launches in the 1970s. Initially, the Voyager missions were conceived as a way to explore the outer planets of our solar system, with the specific goal of sending back detailed data about Jupiter, Saturn, Uranus, and Neptune. However, what started as an ambitious plan for planetary exploration quickly transformed into one of the most enduring and successful space missions in history. Looking back at the path the Voyager spacecraft have taken, it's clear that they were ahead of their time. Voyager 1, launched on September 5, 1977, and Voyager 2, launched 16 days earlier, have both exceeded expectations in terms of longevity, scientific contributions, and the sheer scale of their mission. Each spacecraft was designed to last just 5 years, intended to send back data on the gas giants and their moons before being relegated to history. Now, more than 40 years later, these spacecraft are still operational, and their mission is far from over. Voyager 1's departure from the solar system marked a historic milestone. On August 25, 2012, it crossed the boundary known as the heliopause, the point where the sun's solar wind no longer dominates. This transition into interstellar space was an unprecedented event. No human-made object had ever before ventured this far into the cosmos. The moment Voyager 1 crossed into interstellar space, it began to send back unique information about the surrounding interstellar medium, a region that had been entirely unexplored. The data received from Voyager 1 has provided scientists with a wealth of new insights into the nature of space beyond our sun's influence. In particular, the spacecraft has been instrumental in providing a direct measurement of the density, temperature, and magnetic properties of the space between stars. It's in this remote region of space that Voyager 1's instruments have continued to operate, transmitting invaluable information about the interstellar environment. One of the most profound discoveries made by Voyager 1 in interstellar space was related to the behavior of cosmic rays. These high-energy particles, which travel through space at nearly the speed of light, originate from a variety of sources, including supernovae, black holes, and other cosmic phenomena. Before the Voyager missions, we had little information on the nature of cosmic rays beyond the confines of our solar system. The data from Voyager 1's instruments confirmed that the intensity of cosmic rays in interstellar space is much higher than what is found inside the heliosphere, This discovery opened a new chapter in astrophysics, revealing that the environment of interstellar space is far more intense and unpredictable than we had ever imagined. Voyager 1's ability to detect these cosmic rays is particularly significant because it highlights a fundamental aspect of space exploration. The more we explore, the more we realize how little we truly know. The spacecraft has not only allowed us to gather new data, but it has also highlighted how much more remains to be discovered. There is an incredible amount of knowledge yet to be gleaned from the data sent back by Voyager 1 as it continues to explore regions of space no human has ever seen. At the same time, Voyager 2, which is also venturing into interstellar space, has been providing complementary data. Although Voyager 2 crossed the heliopause 3 years after Voyager 1, in November 2018, its contribution to our understanding of the interstellar medium has been just as crucial. Voyager 2's instruments have been working in tandem with Voyager 1's, helping to confirm and refine the data received from its sibling spacecraft. Together, the two spacecraft provide a comprehensive picture of the conditions in interstellar space, adding layers of understanding to our cosmic map. One of the most enduring aspects of the Voyager missions is how their findings have reshaped our understanding of the solar system itself. The discoveries of new moons around Jupiter, Saturn, and Uranus, as well as the discovery of unexpected phenomena like Saturn's geysers or the magnetic fields around Neptune's moon Triton, were groundbreaking. But even more astonishing were the discoveries of the outer solar system's true nature. These planets were not just gas giants, each had its own complex system of moons, rings, and magnetic fields that revealed more about the forces shaping our cosmic neighborhood. In particular, Voyager 1 and 2's close-up observations of Saturn's rings, the moons of Jupiter, and Neptune's atmosphere provided detailed images and measurements that have become essential in understanding these distant worlds. The Voyager spacecraft didn't just show us the beauty of our solar system's outer planets. They offered insights into how planetary systems form and evolve. For instance, Voyager's observations of Uranus and Neptune challenged many of the assumptions scientists had made about gas giants. These two planets, which were much more mysterious compared to Jupiter and Saturn, were revealed to have unique features, like the extreme tilt of Uranus and the mysterious dark spots on Neptune, that defied expectations. Their exploration offered clues about the forces that shape planetary climates, magnetic fields, and even the possibility of subsurface oceans, as evidenced by the geologically active moon Triton. As Voyager 1 and 2 ventured farther into the unknown, they also provided valuable information on the outer limits of the solar system's protective bubble. The edge of the solar system is not a well-defined line, but more of a gradual transition. As the spacecraft passed through the boundary of the heliosphere and into interstellar space, they provided the first direct measurements of how the solar wind interacts with the surrounding medium, creating a sort of cosmic shield that protects our solar system from the harsh radiation of the broader galaxy. The data provided by Voyager 1 and 2 in this regard has helped astrophysicists understand the nature of this boundary, called the heliopause, and has provided crucial information on the characteristics of the interstellar medium. The spacecraft also continue to provide vital information about the structure of our galaxy. As they move farther from Earth, they will continue to give us valuable data about the nature of the Milky Way, the structure of its magnetic fields, and the cosmic forces that shape its evolution. These measurements are crucial for understanding how stars form and evolve within our galaxy, and they can also provide insights into the broader structure of the universe itself. Moreover, the findings of Voyager the 1st and the 2nd of May helped shape our understanding of how other solar systems function, revealing key information that could be applied to the study of exoplanets in distant star systems. Even as Voyager 1 and 2 push deeper into the vastness of interstellar space, the work they have done and the discoveries they have made will continue to resonate throughout the scientific community for years to come. Each new piece of data received from these spacecraft deepens our understanding of the universe, offering clues about the fundamental forces that govern the cosmos and the mysteries of the universe that still await discovery. The Voyager spacecraft are not just tools for scientific discovery. They are symbols of the unyielding human desire to explore the unknown. They represent our enduring curiosity and our commitment to expanding the boundaries of what is possible in the realm of space exploration. These spacecraft have not only changed the way we see the solar system and the universe, but they have also cemented their place in history as a testament to humanity's pioneering spirit. As we look to the future, the legacy of the Voyager missions will continue to inspire new generations of scientists, engineers, and explorers. The knowledge they have provided will guide future space missions and serve as a foundation for the next wave of exploration beyond our solar system. The discoveries made by Voyager 1 and 2 will be built upon as we strive to understand the broader universe, making the mysteries of the cosmos less elusive and bringing us closer to unraveling the secrets of space itself. And while Voyager 1 and 2 are now embarking on their journeys into the unknown, their impact on humanity's understanding of the cosmos will reverberate for generations. The spacecraft have not only expanded our knowledge of the solar system and the galaxy but have also paved the way for future exploration that will continue to push the boundaries of human knowledge, curiosity, and ambition. As we look to the future, the discoveries made by the Voyager spacecraft are still leaving an indelible mark on the scientific community. Voyager 1 and 2's journey into the deep reaches of space has already transformed the way we think about our solar system and the universe at large. However, their legacy isn't just about their past accomplishments. It's about how the information they continue to send back serves as a stepping stone for the next generation of space exploration. Each day, the spacecraft send back new data, providing insights into the ever-expanding universe and offering clues that could someday unlock the deepest secrets of space. The data being gathered by the Voyagers is changing our view of space in profound ways. For instance, the spacecraft's observations of interstellar space have highlighted the complexity of the environment beyond our solar system. One fascinating finding from the Voyager missions is the detection of a mysterious phenomenon known as cosmic ray modulation. This refers to the way cosmic rays interact with the solar wind in the vicinity of the heliopause, which is the boundary of the solar system's influence. It appears that the intensity of cosmic rays in interstellar space is not uniform and fluctuates as the spacecraft pass through different regions, giving scientists critical information about the dynamics of space that we had never seen before. Cosmic rays are often associated with high-energy particles coming from supernovae, but the fact that they are changing as they pass through the heliosphere provides clues about the environment between stars. The variations in cosmic ray intensity suggest that the conditions of space beyond our solar system are dynamic, and that there are processes at play in interstellar space that we have yet to fully understand. As the Voyagers continue their mission, this ongoing data will undoubtedly lead to further breakthroughs in our understanding of the forces that govern the universe. Another fascinating discovery came from Voyager 2, which in 2018 passed into interstellar space, providing crucial data that corroborated the findings from Voyager 1. While Voyager 1 made its leap into interstellar space earlier, Voyager 2's instruments provided a confirmation of what had been suspected. There is a dramatic shift in the environment between the stars. The data from both spacecraft allowed scientists to confirm that the Sun's influence is indeed a local phenomenon, and once we leave the heliosphere, we are no longer shielded from the broader galactic environment. These findings have been instrumental in shaping our understanding of the boundary between solar and interstellar space. As Voyager 1 and 2 continue their journeys, they are also providing critical data about the magnetic fields of interstellar space. One of the key instruments on each spacecraft is the magnetometer, which measures the strength and direction of magnetic fields. This data has been invaluable in understanding the structure of the magnetic environment beyond the solar system. It's clear that magnetic fields in interstellar space are not only stronger than previously thought, but they also interact in complex ways with the solar wind. This revelation has implications for our understanding of how stars and planetary systems form, as well as how interstellar matter behaves and interacts within the galaxy. In addition to the discoveries of cosmic rays and magnetic fields, the Voyagers have also provided us with fascinating data about the interstellar plasma, which is the gas that exists in space between stars. The interstellar medium is an extremely sparse and diffuse collection of particles, and yet, it plays a critical role in the structure and behavior of our galaxy. Voyager 1's data about the temperature and density of the interstellar plasma has allowed scientists to build better models of how matter behaves on galactic scales. This information will be critical for understanding the life cycles of stars, the formation of new planetary systems, and the evolution of galaxies as a whole. The importance of the Voyager missions goes beyond the discoveries they have made. They also demonstrate the potential for long-term space missions that span decades. When the Voyager spacecraft were launched, they were equipped with technology that was, at the time, cutting edge. Yet, even with advances in technology, the Voyagers have outlasted expectations and continue to transmit data from more than 14 billion miles away. Their longevity is a testament to the robustness of space exploration technology, and serves as a blueprint for future spacecraft missions that will venture into the farthest reaches of space. In the coming years, new technologies will allow us to build upon the Voyager missions and extend the reach of human exploration even farther. The data from the Voyagers is already informing the design of future spacecraft that will venture into the outer reaches of our solar system and beyond. For example, NASA's New Horizons mission, which made history with its flyby of Pluto in 2015, will continue to collect data from the outer solar system. As spacecraft like New Horizons push deeper into unexplored territories, they will rely heavily on the insights provided by the Voyager missions to guide their own discoveries. Furthermore, the Voyagers have paved the way for the study of exoplanets, the countless planets orbiting other stars. With the knowledge gathered from Voyager 1 and 2, scientists now have a deeper understanding of how solar systems, including our own, might have formed. This understanding will prove invaluable as we continue to explore distant stars and search for planets that might harbor life. One of the most profound implications of the Voyager missions is their contribution to our understanding of the potential for life elsewhere in the universe. The spacecraft's journey beyond the solar system also serves as a reminder that, while our own solar system is vast and complex, it is just one tiny part of a much greater cosmos. The data being sent back by Voyager 1 and 2 adds to the growing body of evidence that the universe is filled with an unimaginable variety of environments, and that the possibility of life elsewhere in the cosmos is not a matter of if, but when. Scientists believe that understanding the environments of other stars and planets is essential for identifying the conditions that might support life. While we cannot yet confirm the existence of life beyond Earth, the data from the Voyager missions, along with other space missions, brings us closer to that discovery. Each new bit of information gathered about the interstellar medium, cosmic rays, and other celestial phenomena adds another piece to the puzzle of what makes a planet or a moon capable of supporting life. With future missions, we may one day have the opportunity to explore distant planets with the right conditions for life, making the Voyager discoveries just the beginning of humanity's quest for knowledge. As the spacecraft move farther away from Earth, the data they continue to send back to us will become even more invaluable. The information they provide is not only telling us about the space around them, but it is also shaping our understanding of the universe in profound ways. From cosmic ray measurements to magnetic field readings and plasma density data, Voyager 1 and 2's legacy is one that will continue to influence the course of space exploration for generations to come. Moreover, the ongoing mission of these spacecraft is far from over. Even though both Voyager spacecraft have entered interstellar space, they continue to be active, with their instruments still working to send back important information. Every signal that is received is a victory, a testament to the ingenuity of the engineers who built these spacecraft, the dedication of the scientists who have worked on the mission, and the unyielding curiosity of humanity to explore the unknown. It's remarkable to think that, even now, the Voyager spacecraft continue to transmit valuable data, even though they are far beyond the reach of most of our space technology. As the Voyagers push deeper into the universe, they are doing so not just as pieces of technology, but as representatives of humanity's spirit of exploration. They are helping us to answer questions we've had for centuries. What lies beyond the solar system? How do cosmic forces shape the galaxy? What does interstellar space truly look like? And perhaps most importantly, is Earth unique, or are we just one part of a vast and intricate cosmic web? The answers to these questions will undoubtedly shape the future of space exploration, as new missions take the baton from Voyager 1 and 2 and continue the journey of discovery. These spacecraft may be far from home, but their legacy will live on, forever changing how we see the cosmos. As the years pass, the Voyager spacecraft continue to provide us with invaluable insights, and their mission evolves from exploring the outer planets to becoming messengers from humanity, drifting far beyond the solar system and into the vast expanse of interstellar space. The initial purpose of the Voyager missions was to conduct a grand tour of the outer planets, which they completed successfully. However, as they continued their journey, the spacecraft evolved into something far more significant: scientific probes at the frontier of human knowledge, carrying our legacy across the cosmos. The scientific community is still analyzing the data sent by these spacecraft, and every new transmission holds the potential for further groundbreaking discoveries. One of the most exciting aspects of the Voyager missions is that we are receiving information about regions of space that no spacecraft has ever explored. The Voyagers are the first to travel beyond the influence of our Sun's solar wind, and they are sending back data about this new environment, which is unlike anything we've encountered within the confines of the solar system. Since their departure from the solar system's protective bubble, the Voyagers have been able to study the interstellar medium, the material that exists in the space between stars. The data they've collected gives scientists a clearer picture of what the empty space between stars is really like, filled not with nothingness, but with an extremely sparse collection of gas and cosmic dust. This region of space, though faint, plays a significant role in the dynamics of galaxies and the formation of stars. By studying the interstellar medium, we can begin to understand the life cycle of matter in the galaxy and how stars and planets form over cosmic timescales. One of the most significant contributions from the Voyager missions is the realization that the boundary of the solar system, the edge of the Sun's influence, is far more complex than previously thought. In 2012, Voyager 1 crossed what is called the heliopause, the boundary where the solar wind from our Sun, which had been traveling outward at great speed, finally gives way to the pressure from the galactic winds of the interstellar medium. This was a monumental moment in space exploration, marking the first time a human-made object had crossed into interstellar space. The data from this transition has been invaluable, revealing not only the properties of the space beyond the solar system, but also providing insight into the Sun's influence on the surrounding space. Before the Voyager's journey, scientists believed that the boundary between the solar system and interstellar space was a simple, well-defined barrier, but the data from these spacecraft revealed a much more complicated environment. For instance, the solar wind does not abruptly stop at the heliopause. Instead, the boundary is filled with a turbulent region where the solar wind slows down and interacts with the interstellar medium. The solar wind continues to push outward, but at a much slower rate, until it eventually merges with the galactic winds of interstellar space. This discovery has reshaped our understanding of the solar system's outermost boundaries, illustrating that the space around us is dynamic and full of interactions that we had never anticipated. The new data from the Voyager missions also provides critical insights into the effects of interstellar space on the solar system. Cosmic rays, high-energy particles from outside the solar system, bombard the outer reaches of the heliosphere. Voyager 1 and 2's measurements of these cosmic rays have revealed that the intensity of these rays is higher outside the protective bubble of the Sun's solar wind. The data from the spacecraft is showing that, once you pass beyond the heliosphere, the intensity of cosmic rays from the rest of the galaxy significantly increases, providing clues about the galactic environment and how cosmic radiation might affect the planets and potential habitability of exoplanets. The interstellar space the Voyagers are now traversing is not a vacuum in the traditional sense. Instead, it's a complex and sparsely populated region that is teeming with particles, magnetic fields, and radiation that influence how the universe behaves. For example, Voyager's magnetometers have revealed that the magnetic fields of interstellar space are far more intricate than previously understood. Instead of a uniform, constant magnetic field, the magnetic environment of interstellar space is a complex and turbulent web, with fluctuating fields that influence the movement of charged particles. This discovery has major implications for our understanding of the dynamics of galaxies, the movement of particles, and the formation of stars and planetary systems. In addition to these revelations, the Voyagers are continuing to study the effects of the interstellar environment on the spacecraft itself. With each new transmission, we are learning more about the resilience of spacecraft, even in the harsh conditions of interstellar space. The spacecraft are equipped with instruments that measure the amount of radiation, dust, and other cosmic phenomena that they encounter, giving us invaluable data on the durability of technology used for deep space exploration. These findings are laying the groundwork for future missions to even more distant stars and galaxies, providing us with crucial information about how long-lasting spacecraft technology must be to survive in such an extreme environment. Even though the Voyager spacecraft are far from Earth, their instruments continue to provide crucial data that is helping scientists refine our understanding of the universe. And this knowledge extends beyond just the solar system. The insights the Voyagers are providing about the behavior of matter and energy in interstellar space are informing future projects aimed at exploring the interstellar medium, studying exoplanets, and even considering the potential for interstellar travel. As we move forward with future space exploration endeavors, the lessons from the Voyager missions will remain pivotal in guiding our technological and scientific choices. These spacecraft have proven that long-term missions are possible, even in the most challenging and inhospitable regions of space. The ongoing research and findings from the Voyager spacecraft will continue to serve as a crucial foundation for the missions of tomorrow, missions that might one day seek to explore distant stars and planets in the far reaches of our galaxy. The impact of the Voyager missions will also extend beyond science and technology. Their journey is a story of human curiosity, perseverance, and the unyielding desire to understand the universe around us. As they drift farther from home, the Voyagers carry with them a golden record, a message to any potential extraterrestrial civilizations that may encounter them long after humanity is gone. This message, sent on behalf of Earth's inhabitants, is a symbol of our desire to connect with the universe and explore the unknown. In a sense, the Voyagers are not just scientific instruments, they are cultural ambassadors. Their journey tells a story of human ingenuity, a story that is not limited by borders or time. They are ambassadors from a species that reached beyond its home planet, venturing out into the unknown to learn more about the universe. The Golden Record, which contains sounds and images from Earth, is our way of saying, "We were here. We were curious. We sought knowledge, and we reached for the stars." It's a profound gesture, one that speaks to the heart of what it means to be human. As we continue to look toward the future of space exploration, the lessons learned from the Voyager missions will continue to guide us. The Voyagers have taught us that space exploration is a long-term endeavor, one that requires patience, persistence, and the willingness to explore the unknown. They have shown us that even in the most remote corners of the solar system, there is still much to learn, and that the universe holds many mysteries yet to be discovered. Their legacy is a reminder that the pursuit of knowledge is a never-ending journey, one that spans generations and transcends the boundaries of time and space. While the Voyager missions are nearing the end of their operational lifetimes, their contributions to science and human knowledge are far from over. The data they continue to send back will be analyzed for years to come, offering new insights into the nature of space and our place within it. And in the distant future, as these spacecraft drift forever through the cosmos, they will remain silent messengers from Earth, carrying with them the story of humanity's quest to understand the universe. The Voyager spacecraft represent more than just technological achievements. They are symbols of our collective spirit of exploration. Their discoveries continue to expand the boundaries of what we know and will influence the course of space exploration for generations to come. Even as they journey deeper into the unknown, they remind us of the infinite possibilities that lie ahead in our exploration of the cosmos. As the Voyagers continue their journey into the vast expanse of interstellar space, their contribution to our understanding of the universe only grows. They have crossed boundaries that were once considered unimaginable, sending data back from regions far beyond the reach of any previous human-made object. The discoveries they have made at the very edge of the solar system are not just scientific revelations, but a testament to the enduring human spirit of curiosity and exploration. One of the most fascinating aspects of the Voyager missions is the way they have changed our perception of space itself. Prior to their launch, scientists had little direct data about what lay beyond the edge of the solar system, where the Sun's influence was no longer the dominant force. Voyager 1's crossing into interstellar space in 2012 provided us with our first direct measurements of the interstellar medium, the material that exists between stars in a galaxy. The spacecraft revealed that this region, while seemingly empty, is filled with diffuse gas and dust. These particles are incredibly sparse, but they still have a profound effect on the movement of stars, the formation of new solar systems, and the propagation of light across the galaxy. This region of space has also proven to be a treasure trove of cosmic radiation. As Voyager 1 left the protection of the solar wind, it encountered a significant increase in cosmic rays, high-energy particles originating from distant supernovae and other astrophysical phenomena. These particles bombard the spacecraft from all directions, giving scientists new data on the composition and intensity of the radiation that permeates the galaxy. The cosmic rays observed by the Voyager spacecraft offer important clues about the behavior of matter in interstellar space, the evolution of stars, and the overall dynamics of the galaxy. They also provide insight into the potential hazards for future deep space missions, as cosmic radiation can pose serious risks to astronauts venturing beyond Earth's protective atmosphere. Perhaps one of the most surprising discoveries made by the Voyager spacecraft involves the nature of the magnetic field in interstellar space. For decades, scientists had assumed that the magnetic field outside of the solar system would be relatively uniform and weak. However, the data sent back by the Voyagers have shown that the magnetic field in interstellar space is far more complex than anticipated. Voyager 1, for example, has detected swirling magnetic fields that appear to be intertwined with the galactic magnetic field. These fields are not static but fluctuate in intensity and direction, creating a dynamic environment that is vastly different from the relatively stable magnetic field of the Sun. This discovery is significant because it sheds new light on the role of magnetic fields in shaping the evolution of galaxies and star systems. The interstellar magnetic field appears to play a key role in regulating the flow of charged particles, which in turn affects the formation of new stars and planets. By studying these magnetic fields, scientists hope to gain a deeper understanding of how galaxies are structured and how stars and planets come into being. As the Voyagers continue to travel deeper into interstellar space, they are also shedding light on the nature of the solar system's outermost regions. The spacecraft's instruments have been able to measure the density and temperature of the interstellar medium, giving us valuable insights into the conditions of the space surrounding the solar system. These measurements have revealed that the interstellar medium is far denser and hotter than previously thought, with temperatures reaching hundreds of thousands of degrees. This discovery has profound implications for our understanding of the behavior of matter in the universe and the processes that govern the formation of stars and galaxies. In addition to these groundbreaking discoveries, the Voyagers have also provided new insights into the structure of the solar system itself. While the Voyagers' primary mission was to explore the outer planets, their data has helped scientists refine our understanding of the solar system's boundaries. The spacecraft have revealed that the outermost regions of the solar system are far more complex than previously imagined. The heliosphere, the bubble of solar wind that surrounds the solar system, is not a smooth, uniform structure but a turbulent, ever-changing environment. This discovery has challenged our assumptions about the solar system's outer boundaries and has led to new theories about how the Sun's influence extends throughout the galaxy. These findings have far-reaching implications for our understanding of space travel and the future of human exploration. The data from the Voyager spacecraft are helping to inform the design of future missions, particularly those aimed at exploring the outer reaches of our solar system and beyond. By understanding the complexities of the interstellar medium and the behavior of cosmic radiation, scientists can develop more effective shielding and protective measures for spacecraft, making deep space travel safer for future astronauts. The legacy of the Voyager missions extends far beyond the immediate discoveries they have made. These spacecraft are not just scientific instruments. They are symbols of human ingenuity and perseverance. The fact that Voyager 1 and 2 are still sending back data from over 14 billion miles away is a remarkable achievement that underscores the capabilities of modern space exploration. It is a testament to the vision of the scientists, engineers, and astronauts who made these missions possible, and it serves as an inspiration for future generations of explorers. Even as the Voyagers journey farther from Earth, their contributions to science continue to resonate across the world. The data they have gathered has reshaped our understanding of the universe and opened up new avenues of research that were once thought to be beyond our reach. The Voyager missions have taught us that there is still so much to learn about the universe, and that the pursuit of knowledge is an endless journey. As long as the Voyagers continue to send back data, they will remain at the forefront of human exploration, offering new insights into the mysteries of space and helping to expand our understanding of the cosmos. Looking forward, the legacy of the Voyager spacecraft will continue to influence the direction of space exploration for decades to come. The discoveries made by the Voyagers have paved the way for new missions that will explore the outer planets, study the interstellar medium, and ultimately seek to answer some of the most profound questions about the nature of the universe. As we continue to look to the stars, the Voyagers will remain a beacon of human curiosity and a symbol of our unyielding desire to explore the unknown. In the grand scheme of the cosmos, the Voyager's journey is just a tiny step, a brief moment in the vast expanse of space and time. Yet, their discoveries have forever changed the way we view the universe. These spacecraft have given us a glimpse of the unknown, a peek into the mysteries that lie beyond the reach of our current technology. As they continue their journey into the great beyond, the Voyagers remind us that there is always more to discover, and that the pursuit of knowledge is a journey that knows no bounds. Their discoveries are not just scientific, they are philosophical, inspiring us to contemplate our place in the universe and the future of humanity. The Voyager missions have taught us that, no matter how far we travel or how many obstacles we face, the quest for knowledge is worth pursuing. And as we continue to venture deeper into the cosmos, we can look to the Voyagers for inspiration, knowing that their journey is not just about exploring distant worlds, but about exploring the very nature of existence itself. As the Voyager spacecraft venture further into interstellar space, their data has begun to offer insights that were previously unimaginable. Despite the enormous distances between the spacecraft and Earth, the data they continue to transmit is painting a clearer picture of the cosmos beyond our solar system, revealing its complexities and intricacies in a way that was once thought impossible. The impact of the Voyager's discoveries is not confined to just the realm of astrophysics. The results of their missions have ripple effects across various fields of science, from the study of cosmic radiation to the understanding of interstellar travel. One of the most important findings from the Voyagers involves the behavior of the interstellar medium. For centuries, scientists speculated about what lay beyond the protective shield of the solar wind. With Voyager 1 now beyond this protective barrier, we have learned that interstellar space is not a complete vacuum, but rather a region teeming with particles and radiation. These particles are not uniform. They vary in density and temperature, and they interact in complex ways with the magnetic fields present in the galaxy. This new understanding of the interstellar medium provides valuable insights into the nature of the Milky Way itself, revealing that our solar system exists in a dynamic, ever-changing environment that is far more complex than initially thought. The solar wind, which had been pushing outward from the sun and creating a bubble of charged particles around the solar system, gradually weakens as Voyager 1 travels farther from the sun. At the boundary of this bubble, the spacecraft encountered a sharp shift in the characteristics of the environment, signaling its entry into interstellar space. This dramatic change was the first concrete proof that the region beyond our solar system is a distinct environment, governed by forces that differ from those that dominate the inner solar system. As Voyager 1 crossed this boundary, it detected a sudden increase in the density of cosmic rays, high-energy particles that originate from distant supernovae and other astrophysical events. This was the first direct measurement of the true cosmic ray environment in the outer regions of the Milky Way. But the most stunning discovery lies in how these particles affect our understanding of the broader cosmos. The data collected from Voyager 1 shows that these high-energy particles have traveled across the galaxy, originating from unknown sources and interacting with the interstellar magnetic fields. This phenomenon is not just a random cosmic event but provides crucial information about the processes that govern the life cycle of stars and galaxies. The fact that these cosmic rays penetrate through the interstellar medium and provide us with valuable data challenges our assumptions about how energy and matter interact in the vast emptiness of space. The information gathered by Voyager 1's instruments has fundamentally altered our understanding of the solar system's outer boundaries. It turns out that the region around the solar system is not a smooth, homogeneous zone, but rather a turbulent and complex boundary. As Voyager 1 passed through the outer reaches of the heliosphere, it observed intricate magnetic field lines that were much more chaotic than expected. These magnetic fields are believed to be generated by the motion of charged particles within the interstellar medium, creating a dynamic and ever-changing environment in which the spacecraft finds itself. This discovery has raised intriguing questions about the role of magnetic fields in regulating the flow of matter and energy throughout the galaxy. The magnetic fields surrounding the spacecraft are not only more complex than anticipated, but they also appear to interact with the interstellar medium in unexpected ways. This new data has important implications for the study of galactic magnetic fields and how they shape the behavior of charged particles within them. The interaction between these magnetic fields is believed to influence the rate at which stars are formed, the propagation of cosmic radiation, and the structure of the galaxy itself. The fact that the Voyager spacecraft are measuring these fields from such a remote location allows scientists to test theories that could not have been confirmed otherwise. As Voyager 2 follows a similar path, scientists are eager to compare the data from both spacecraft. Voyager 2, which took a slightly different trajectory, has provided a unique perspective on the outer reaches of the solar system. Early findings from Voyager 2 have confirmed that the interstellar medium is not just a static environment, but is constantly evolving. This means that the solar system's outer regions are not only influenced by the Sun but also by the activity of distant stars, supernovae, and other cosmic phenomena. The data from both spacecraft will help scientists understand how these forces interact and what role they play in shaping the structure and evolution of the galaxy. Perhaps one of the most intriguing aspects of the Voyager missions is the possibility that these spacecraft could encounter other forms of extraterrestrial phenomena. While the Voyagers are currently traversing the vast emptiness of interstellar space, they may eventually pass through regions of the galaxy that are home to phenomena that we have not yet discovered. The data collected by these spacecraft could, one day, provide the first evidence of exotic phenomena like dark matter or even evidence of other civilizations. Voyager 1's journey is not just a testament to human ingenuity, it is a glimpse into the future of space exploration. The spacecraft continues to provide data that will be studied for years to come. As technology advances, future missions will build upon the knowledge that the Voyagers have provided. What makes the Voyager missions particularly extraordinary is the fact that they are the longest operating spacecraft in human history. Their journey is not just one of scientific exploration, it is a testament to the resilience of human engineering and a symbol of humanity's unwavering curiosity about the universe. Even as the Voyager spacecraft travel farther from Earth, their legacy continues to influence the development of future space missions. The discoveries they have made have reshaped the way scientists think about the solar system and the galaxy. The idea of exploring interstellar space was once thought to be a distant dream, but the data returned by Voyager 1 and 2 prove that such exploration is not only possible but is also yielding fascinating insights into the nature of the cosmos. Looking ahead, the potential for future discoveries is immense. As the Voyagers continue to travel through the interstellar medium, they will encounter regions of space that are entirely unexplored. The data they send back could help answer some of the most profound questions about the universe. How do stars form? What role does magnetic energy play in galactic evolution? What is the true nature of the interstellar medium? And perhaps most intriguingly, are we alone in the cosmos? The questions raised by the Voyager missions have opened up new avenues of research, and the data they have provided will continue to fuel scientific inquiry for years to come. But beyond the scientific significance, the Voyagers represent something deeper, the enduring human spirit of exploration. These spacecraft are symbols of our relentless pursuit of knowledge, our desire to understand the universe, and our unyielding curiosity about what lies beyond the stars. As they continue their journey into the unknown, the Voyager spacecraft remind us that space exploration is not just about what we can see, but also about what we can imagine. The mysteries of the cosmos are vast, and while we may never have all the answers, the journey itself is an essential part of the human experience. With each passing day, the Voyagers continue to push the boundaries of what we know, and in doing so, they inspire generations of scientists, engineers, and explorers to continue reaching for the stars. As Voyager 1 and Voyager 2 continue their journey into the vastness of interstellar space, they remain a beacon of human achievement and curiosity. Even though both spacecraft are now so far from Earth that their signals take over 20 hours to reach us, their mission is far from over. In fact, their voyage is only just beginning in terms of the groundbreaking discoveries yet to be made. Each day, their instruments send back data that offers a unique perspective on the universe that no other human-made object has ever been able to offer. While Voyager 1 has already crossed the threshold into interstellar space, Voyager 2 is still in the outer boundary of the heliosphere, the bubble of charged particles that the Sun emits, on its way to crossing the same threshold. This means that both spacecraft are providing complementary data that will allow scientists to better understand the transition from the Sun's influence to the mysterious expanse of interstellar space. The sheer scale of these discoveries is staggering, and while we have only begun to scratch the surface, the Voyager's legacy is already immense. The most profound realization stemming from these missions is the confirmation that the solar system, as we have long understood it, has an end. For generations, the idea that our Sun's influence might stretch into infinity was an assumption in the scientific community. Now, however, thanks to Voyager 1's crossing into interstellar space, we know that the Sun's magnetic field and solar wind do, in fact, dissipate and give way to the overwhelming vastness of space. This fundamental shift has had significant implications for how scientists model the solar system and the interstellar environment. As Voyager 1 enters this uncharted territory, the spacecraft continues to send data that paints a picture of an environment vastly different from the one within the protective shield of the solar wind. For example, Voyager 1 has detected a rise in cosmic rays, high-energy particles that are constantly bombarding the solar system from all directions. These particles are produced in distant regions of the galaxy by violent events such as supernovae, and their increase in number as Voyager 1 moves farther from the Sun is one of the clearest signs of the transition from the solar system's heliosphere to interstellar space. Perhaps even more surprising than the cosmic ray data are the findings about the interstellar magnetic fields. The Voyager spacecraft have provided the first direct measurements of these fields, which are believed to be created by the motion of charged particles in the interstellar medium. These fields are not only far more complex than initially anticipated, but they also seem to be interacting with the solar wind in ways that scientists are still trying to fully comprehend. What we are beginning to realize is that the solar system is not a lonely, isolated bubble in the vast emptiness of space, but rather part of a much larger, dynamic galactic environment. This realization opens up countless questions about the true nature of the solar system's position in the galaxy. As Voyager 1 travels deeper into interstellar space, scientists are also beginning to examine the behavior of the spacecraft's instruments in this new environment. As expected, the solar wind is no longer a dominant force, and the spacecraft's instruments have begun to observe a dramatic change in the plasma environment. The density of the particles in this region is not uniform. In some areas, it is far more intense than what the spacecraft experienced in the outer regions of the heliosphere. These observations have led scientists to reevaluate how they model the interstellar medium and its interaction with solar wind. This new data has also opened up questions about the structure of the Milky Way itself. For decades, scientists have wondered how the solar system fits into the larger galactic structure. Voyager 1's observations have suggested that the galaxy's magnetic fields and cosmic ray distribution are far more complex and dynamic than originally thought. These fields are thought to influence the behavior of stars, as well as the formation of new stars and planetary systems. In addition, the distribution of cosmic rays offers insight into the violent processes occurring in the galaxy, such as supernova explosions and the formation of black holes. The data from Voyager 1 allows scientists to map the density of these high-energy particles across the galaxy, providing a more detailed understanding of its overall structure. In addition to the groundbreaking scientific discoveries, there is an emotional and philosophical aspect to the Voyager missions that is impossible to ignore. As the spacecraft move farther from Earth, they continue to represent humanity's collective desire to understand the universe. Voyager 1's famous pale blue dot image, taken in 1990, showed Earth from a distance of over 3.7 billion miles, a tiny speck of light in the vastness of space. This image became a symbol of humanity's fragility and the preciousness of our existence. As the Voyagers journey farther into space, they carry with them a message not only about the technological prowess of humanity, but also about the shared sense of wonder that unites us in the pursuit of knowledge. The Golden Record, which was carried aboard both Voyager 1 and Voyager 2, serves as a time capsule for any intelligent life that may one day find these spacecraft. The record contains sounds and images representing humanity, our culture, and our planet, with the hope that it might offer some insight into our civilization for future explorers. This artifact, made of gold-plated copper, is an enduring symbol of human curiosity and the desire to connect with the unknown. The Golden Record, however, is not just a symbol of our desire to communicate with extraterrestrial civilizations, it is also a reflection of our deep-seated desire to understand our place in the cosmos. As the Voyager spacecraft continue their journey, they remain in communication with Earth, though the signals they send back take longer and longer to reach us. Voyager 1's signal now takes over 22 hours to travel one way, and that time will only continue to increase as the spacecraft moves farther from Earth. Even though the spacecraft's power is steadily diminishing and they are expected to stop transmitting data within the next decade, their legacy will endure long beyond their operational lifespan. The data they have collected will continue to shape our understanding of the universe, and their journey will inspire future generations of scientists, explorers, and dreamers. Looking ahead, the future of space exploration is filled with even greater possibilities. The Voyagers have opened the door to a new era of interstellar exploration, one in which we are no longer confined to the bounds of our solar system. The knowledge we have gained from these missions will serve as the foundation for future missions that will venture even farther into space. Technologies that we are currently developing, such as the proposed Breakthrough Starshot initiative, aim to send small spacecraft to the nearest star systems in just a few decades. These missions, inspired by the Voyager legacy, will continue the quest to explore the unknown and answer the most profound questions about the universe. But for now, Voyager 1 and 2 remain humanity's furthest outposts in the cosmos. Their data, which continues to flow back to Earth at a trickle, will help us unlock the secrets of the universe in ways we could never have imagined before these missions began. And as these spacecraft drift into the deep, dark expanse of interstellar space, they carry with them the hopes and dreams of all humanity, exploring the unknown in ways that no one before them ever had the chance to do. With each passing year, the discoveries they continue to make will remind us of the vastness of the universe and our place within it, and they will continue to inspire future generations of explorers to look up and wonder, what lies beyond? As the Voyager spacecraft continue their journey into the deep, cold unknown, they represent much more than just technological marvels. They symbolize humanity's insatiable curiosity, our eternal quest for knowledge, and the determination to reach beyond our familiar horizons, even when the destination is beyond our current understanding. The data that these spacecraft continue to send back has profound implications not only for science but for our place in the universe. The edge of the solar system is no longer an abstract boundary, it is a real, measurable frontier. One of the most remarkable aspects of the Voyager missions is the way they have expanded our perception of space. For generations, the boundary of our solar system was defined by the outermost planet, Neptune, and the final frontier was thought to be the boundary of our Sun's influence. Now, thanks to Voyager 1's journey beyond the heliosphere, we know that the solar system stretches far beyond Neptune, and the true boundary of the Sun's influence is defined not by a planet but by the reach of the Sun's magnetic field and solar wind. This transition is not a sharp, clearly defined line but rather a gradual fade into the interstellar medium, a vast region of space filled with the remnants of dying stars, high-energy cosmic rays, and magnetic fields that we are just beginning to understand. The data coming back from Voyager 1 as it crosses into interstellar space continues to surprise scientists. Early theories suggested that this region would be relatively stable, with little change in the environment. However, the data has shown a much more dynamic picture, one that reflects the complexity and unpredictability of the universe. The cosmic ray environment, for example, is far more intense than expected, with the spacecraft detecting a surge in high-energy particles as it moves farther from the Sun's protective bubble. This increase in cosmic rays has led to new questions about the nature of these particles and their origins. Some scientists speculate that the sudden increase in cosmic ray density could be caused by the interaction between the solar wind and the magnetic fields of nearby stars, while others suggest that the energy levels are a result of our Sun moving through a dense region of the interstellar medium. In addition to the increase in cosmic rays, Voyager 1 has also observed strange fluctuations in the plasma environment of interstellar space. The plasma that fills the space between stars is not uniform, and the density of particles can vary significantly depending on the region. This has led to new models of how solar systems interact with the galactic environment, with some theories suggesting that the solar system may be passing through a galactic cloud, a region of space where the density of interstellar material is higher than normal. These new discoveries challenge existing models of the interstellar medium and provide new insights into how stars and planets form and evolve over time. What makes these discoveries even more astounding is that Voyager 1 is making them while traveling through space at speeds unimaginable to us on Earth. Moving at over 38,000 miles per hour, the spacecraft is still sending back valuable data after more than 45 years in space. This means that the discoveries we are making today are the result of technology that was built and launched in the 1970s, a testament to the ingenuity and foresight of the scientists and engineers who designed the spacecraft. Despite the distance between Voyager 1 and Earth, the spacecraft's instruments are still functioning remarkably well, transmitting data that is helping scientists rewrite textbooks and expand our understanding of the cosmos. Even as Voyager 1 continues to explore the mysteries of the interstellar medium, its counterpart, Voyager 2, is not far behind. Voyager 2, which crossed into interstellar space in 2018, is also providing a wealth of information that complements the findings of Voyager 1. The two spacecraft are on similar trajectories but are separated by billions of miles, and the data they are collecting is helping to create a more detailed picture of the environment at the edge of the solar system. Together, they are offering a unique opportunity to compare and contrast the conditions in different regions of interstellar space, which could reveal new insights into the nature of the universe itself. The importance of the Voyager missions cannot be overstated. They have expanded our understanding of the universe in ways that no other mission has been able to do. They have shown us the reality of the solar system's boundaries, confirmed the existence of interstellar space, and provided unprecedented data on the cosmic environment that surrounds us. But perhaps most importantly, they have reminded us of the power of exploration and the human drive to understand the unknown. The Voyager spacecraft are far more than just pieces of technology. They are symbols of what we can accomplish when we dare to venture beyond what we know. And while Voyager the 1st and the 2nd of May eventually lose their ability to transmit data back to Earth, their legacy will endure for generations. The discoveries they have made will continue to shape our understanding of the universe for decades to come, and their mission will serve as an inspiration for future explorers who will carry the torch of interstellar exploration into new and unknown frontiers. Looking forward, the quest for knowledge does not end with the Voyager spacecraft. Humanity's reach into space is only just beginning. Already, plans are being made to send new missions into deep space, including the possibility of sending robotic spacecraft to the nearest stars. The technological advancements that have allowed the Voyager spacecraft to operate for so long will serve as the foundation for these future missions, and the data collected by Voyager 1 and 2 will guide the way forward. The dream of exploring other star systems is no longer a far-off fantasy but a tangible goal that we are slowly but surely moving toward. The Voyager missions are a remarkable testament to human curiosity, determination, and the desire to understand the universe. The discoveries that have been made at the edge of the solar system are only the beginning of a much larger story, one that will continue to unfold as we push the boundaries of space exploration. Voyager 1 and 2 have proven that, even in the vast emptiness of space, there is much to be learned and discovered. As they continue their journeys into the unknown, they carry with them the hopes and dreams of humanity, inspiring us all to look up and ask, What's out there? The legacy of the Voyager spacecraft is not just about the technology or the data they have provided. It is about the questions they have raised, the mysteries they have uncovered, and the future they have paved for the next generation of explorers. They have reminded us that the pursuit of knowledge is never-ending, and that there is always more to discover beyond the horizon. So, as Voyager 1 drifts farther and farther from Earth, and as Voyager 2 follows closely behind, we can only imagine what new revelations will be made as they continue their long, silent journey through the depths of interstellar space. With each passing year, their mission becomes more significant, their discoveries more profound, and their impact on humanity's understanding of the cosmos ever more lasting. And as we wait for the next groundbreaking revelation, we can look back with pride at what these spacecraft have already achieved, and with excitement for the possibilities that lie ahead. As Voyager 1 and 2 continue their slow, yet relentless journey across the vast emptiness of space, they are not merely drifting away from Earth. They are pushing the boundaries of our understanding and laying the groundwork for humanity's future explorations in the cosmos. The two spacecraft, though aging, continue to send us new revelations, each one transforming our understanding of the universe around us. Their data have not only reshaped our view of the solar system's outer reaches but have also posed new questions about the fundamental workings of the cosmos itself. One of the most astonishing aspects of the Voyager missions is how they have continually exceeded expectations. Initially, these spacecraft were only designed for a journey to the outer planets of our solar system, and once they completed their flybys of Jupiter, Saturn, Uranus, and Neptune, it was thought that they would have nothing more to contribute. However, their mission has been extended, with each passing year revealing new surprises that continue to intrigue scientists and astronomers alike. Voyager 1's crossing into interstellar space in 2012 was a momentous milestone that confirmed the boundaries of the solar system were far more expansive than we had ever imagined. In fact, Voyager 1's crossing of the heliopause, the boundary where the solar wind from the Sun weakens and merges with the interstellar medium, marked the beginning of a new chapter in space exploration. As the spacecraft journeyed farther and farther from the Sun, scientists began to see the space beyond the solar system in ways never before possible. The Voyager spacecraft's most significant contribution at this point has been providing the first ever direct observations of the interstellar medium, the vast, mostly empty space between the stars that fills the galaxy. This medium is composed of low-density gas, plasma, and cosmic rays, and until the Voyagers entered this realm, our knowledge of it was purely theoretical. These insights have already changed the way we view space. The interstellar space that Voyager 1 entered isn't the serene, calm void that some might expect. Instead, it's a turbulent region filled with cosmic rays, high-energy particles, and magnetic fields that are just beginning to reveal their secrets. One of the most surprising findings is the changing nature of the plasma in this area. Scientists were expecting that the transition from the relatively calm solar wind to the chaotic plasma of interstellar space would be sudden, but it turns out that the shift is gradual, and the characteristics of the plasma remain in flux. In fact, the scientists have noted distinct differences between the plasma Voyager 1 encounters compared to what was anticipated, which further complicates our understanding of the boundary regions between solar systems. For example, as Voyager 1 travels deeper into interstellar space, the plasma density that it is measuring has fluctuated in ways that challenge existing models of how plasma behaves in such an environment. The spacecraft has recorded plasma wave measurements that indicate a dense, cloudy, region of space that wasn't expected. These dense plasma clouds may be the result of local astrophysical phenomena, such as remnants of supernovae or interactions between interstellar particles and cosmic radiation. But understanding these fluctuations requires further data, and Voyager 1 continues to beam back information that scientists will analyze for years to come. One key observation that has continued to intrigue researchers is the unusual magnetic field environment detected by Voyager 1. Initially, scientists thought that, after Voyager left the protective bubble of the Sun's magnetic influence, the spacecraft would encounter the magnetic fields of the interstellar medium, which should have been weaker and more chaotic. But the data revealed a much more complex magnetic environment. Instead of the expected gradual transition, Voyager 1 has detected ripples and oscillations in the magnetic fields, which suggests that the interstellar magnetic field is far more structured and organized than previously believed. This could have profound implications for our understanding of the formation of stars and galaxies, as magnetic fields play a critical role in these processes. These findings are significant not just for the study of the outer solar system or interstellar space, but also for the broader field of astrophysics. In many ways, Voyager's journey has begun to answer fundamental questions that have long puzzled astronomers. How do interstellar magnetic fields work? What is the true nature of the interstellar medium? How do cosmic rays behave beyond the solar system? These are questions that Voyager's discoveries have already begun to address, but the spacecraft's mission is far from over. As the spacecraft travels further from Earth, the insights it provides will only deepen, helping us better understand the very fabric of the universe. The role of the Voyager spacecraft in the scientific community extends far beyond their immediate findings. They have demonstrated the incredible endurance and potential of space exploration technologies, providing a shining example of the benefits of long-term scientific missions. The fact that Voyager 1 continues to transmit data after over 45 years of operation is a testament to the robustness and foresight of the engineers who designed it. The spacecraft's longevity is a shining example of the potential for future missions to last far longer than anyone could have predicted, offering hope that humanity can undertake even more ambitious exploration projects in the future. Looking toward the future, the legacy of the Voyager missions will undoubtedly play a central role in humanity's continued exploration of space. The data collected by these spacecraft is not only valuable in its own right but also serves as a benchmark for future missions. The lessons learned from the design, operation, and findings of the Voyager spacecraft will be crucial as we plan future missions to distant worlds and even other star systems. In particular, the technologies developed for the Voyagers, from their communication systems to their power sources, will inform the design of upcoming spacecraft intended for long-duration missions. The Voyager spacecraft may also inspire new generations of scientists, engineers, and explorers. These missions have captured the imagination of millions around the world, proving that even with limited resources, humanity can achieve great things. The Voyager program has shown that the pursuit of knowledge is a long, difficult journey, but one that rewards us with profound insights into the universe. The discoveries made by Voyager 1 and 2 will likely continue to shape the field of astrophysics for decades to come, and the spacecraft's success will serve as a model for future missions that will push even further into the unknown. The value of the Voyager missions goes beyond the scientific data they have returned. They also carry a symbolic message. Both Voyager 1 and 2 carry golden records, which contains sounds and images meant to represent humanity and its diverse cultures. These records were launched with the spacecraft as a way to communicate with any potential extraterrestrial civilizations they might encounter. This idea of sending a message beyond our solar system is a powerful reminder of humanity's longing to reach beyond our own world and make contact with the greater cosmos. In this sense, the Voyager spacecraft are not only scientific instruments but also cultural ambassadors, carrying a piece of humanity into the farthest reaches of space. Even as Voyager 1 and 2 continue their journey into the vast expanse of interstellar space, the questions they have raised will continue to challenge our understanding of the universe. What lies beyond the regions they are exploring? Will we one day detect signs of life or other intelligent civilizations out there? How does the sun's influence shape the galaxy? And what role does our solar system play in the broader structure of the universe? These questions, and many more, will shape the direction of future scientific missions and guide humanity as we venture further into the cosmos. As the Voyager spacecraft drift ever outward beyond the reach of human hands, they will continue to provide us with clues about the universe and our place in it. Each new discovery, each new piece of data, brings us closer to answering some of the deepest questions we've ever asked. And as they journey toward the unknown, the Voyagers remind us that, no matter how vast or how mysterious the universe may be, humanity's thirst for knowledge will always drive us to explore it, one discovery at a time. As the years stretch on and the Voyagers move further into the unknown, the legacy of these space probes becomes more profound. Their missions, which once seemed to be limited to a specific set of tasks, have become emblematic of humanity's unyielding drive to explore, to understand, and to push the boundaries of what's possible. While Voyager 1 is the furthest human-made object from Earth, it's not just the physical distance that makes these spacecraft so monumental, it's the scientific discoveries they continue to make, the fundamental truths they are uncovering about the universe. One of the most remarkable aspects of the Voyager missions is the way they have continually exceeded expectations. After both spacecraft completed their primary missions of exploring the outer planets, it was assumed that they would simply continue to drift into the unknown, transmitting data until their power sources ran dry. However, the unexpected longevity and continued data transmission from both Voyagers have kept scientists on the edge of their seats. The spacecraft are now revealing an entirely new chapter in our understanding of the universe, one that is filled with complexities and phenomena that we had never imagined. Voyager 1's journey into interstellar space has revealed that the space beyond the solar system is far more intricate and dynamic than scientists could have anticipated. Initially, it was thought that once the spacecraft crossed the heliopause, the boundary where the sun's solar wind no longer dominates, it would encounter an almost empty, quiet region of space. However, what Voyager 1 has found is much more dynamic and surprising. The interstellar medium, the matter and radiation that exists between stars in a galaxy, is not the quiet, tranquil expanse we once imagined. Instead, Voyager has revealed that this region is filled with a variety of particles, magnetic fields, and cosmic rays, all interacting in ways that were previously unknown. Perhaps one of the most surprising discoveries came from the detection of cosmic rays. While these high-energy particles have been detected in the solar system, their behavior in the interstellar medium is quite different. Voyager 1 has detected an increase in the intensity of these cosmic rays as it travels further from the Sun. This discovery has shed new light on the nature of cosmic radiation and has led scientists to rethink the way it propagates through space. It turns out that the interstellar medium is not a simple, uniform expanse but a complex and turbulent environment that has far more interaction with cosmic particles than we realized. Even more intriguing are the unexpected fluctuations in the magnetic field. Voyager 1 has been measuring the magnetic environment beyond the solar system, and the results have been far from straightforward. It was initially expected that once the spacecraft left the influence of the Sun's magnetic field, it would encounter a relatively calm and weak interstellar magnetic field. Instead, it has found that the interstellar magnetic field is highly structured, with unexpected ripples and fluctuations that defy earlier expectations. These findings have had a profound impact on our understanding of magnetic fields in interstellar space and could have significant implications for how we study the formation of galaxies and stars. Moreover, Voyager's data regarding the plasma waves in interstellar space have challenged our understanding of how plasma behaves in such an environment. Scientists had assumed that once the spacecraft crossed into the interstellar medium, they would encounter a more uniform plasma, with minimal variations. However, Voyager 1 has measured plasma waves that fluctuate in density and intensity, suggesting a far more complex and dynamic environment. This data will undoubtedly inspire a re-examination of how plasma behaves in the vast stretches of space between stars. Even the basic conditions of space beyond the solar system are being reconsidered in light of the information from the Voyagers. Previously, it was believed that the transition from the heliosphere, the bubble created by the Sun's solar wind, to interstellar space would be a relatively smooth and well-understood process. Instead, the boundaries are much more nebulous, with complex interactions between particles and fields that are still not fully understood. Voyager 1 has not only crossed into interstellar space but has also begun to offer us a glimpse of what lies beyond the solar system in a way that no previous mission could have. The data sent back from Voyager 1 and 2, however, does more than simply expand our scientific knowledge. It forces us to confront deeper existential questions. As Voyager 1 sails further into the unknown, it carries with it the Golden Record, a message to any extraterrestrial civilization that might come across it one day. This Golden Record is a time capsule, containing sounds and images meant to represent humanity, and its diverse cultures, ideas, and achievements. It's a humbling reminder that, in the grand scheme of the cosmos, our existence is fleeting and fragile. Yet we have sent out a message to the stars, saying that we were here, that we understood the vastness of space, and that we sought to make contact with others. The philosophical implications of the Golden Record are profound. It's not just a scientific artifact, it's a statement of humanity's place in the universe. By sending this message, we are acknowledging the possibility of life beyond Earth, and more importantly, we are declaring that we are part of something much larger than ourselves. This is the human spirit at its most optimistic, reaching out into the unknown with the hope that, someday, we may not be alone in the universe. This message, sent on a small, unassuming spacecraft that now drifts in interstellar space, encapsulates humanity's enduring curiosity and desire for connection. Yet, while the Voyager's journey is a symbol of our far-reaching ambitions, it also represents the sheer scale and incomprehensible distances that define our universe. Voyager 1's data suggests that even the closest stars and the interstellar medium itself are vastly more complex than we can imagine. These findings challenge us to reconsider our place in the cosmos, not as the center of it all, but as a small part of a vast and mysterious universe filled with phenomena that are beyond our current understanding. The ongoing success of the Voyager missions is a testament to the vision and ingenuity of those who conceived and built them. The spacecraft were designed for a mission that was expected to last only a few years. Yet, after more than 4 decades, they continue to send back valuable data, revolutionizing our understanding of space in ways that were once thought impossible. This continued success opens the door to future missions that will explore even more distant regions of space, bringing us closer to answering some of the most fundamental questions about the universe. Looking ahead, the future of space exploration is deeply intertwined with the legacy of the Voyager missions. As the spacecraft continue their journey into the unknown, they are paving the way for more advanced missions that will push even further into interstellar space. While the Voyagers are aging and their power is running low, the lessons learned from their design, operation, and discoveries will inform the next generation of space missions. The technologies that have enabled Voyager to survive for so long in the harsh conditions of space will be critical for designing future spacecraft that will venture even further. Furthermore, the Voyager missions have sparked new interest in space exploration and have inspired generations of scientists, engineers, and explorers. The Voyagers remind us that the quest for knowledge is not always easy, but the rewards are immeasurable. As humanity continues to reach for the stars, the Voyager spacecraft will always stand as a symbol of our ambition, our curiosity, and our unyielding desire to understand the universe around us. In many ways, the Voyagers represent the culmination of centuries of human curiosity about the cosmos. They are the product of humanity's age-old quest to understand the stars, to explore the unknown, and to discover our place in the universe. As they continue their journey through the vast emptiness of interstellar space, they carry with them the hopes and dreams of an entire civilization, and they remind us that, in the grand scale of the cosmos, we are not so insignificant after all. The incredible discoveries made by Voyager 1 and 2 have opened our eyes to the complexity of the universe and the mysteries that lie beyond our solar system. They have revealed a universe far more intricate than we could have imagined, full of dynamic forces, strange phenomena, and uncharted territories. And as we look to the future, we can only imagine what new revelations will come from the Voyager's continuing journey into the cosmos. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.